Hello people, this is the planned hangout. It's probably not where I thought it was going to be. I don't know what G Plus is doing, but trying to start these things has become an exercise in futility. And so I'm just using my instant link, so it's not where you'd expect it to be. I hope you'll bear with me. And the other thing is this. The plan for this evening is that those who have questions that they want answered can either ask their question in the comment section underneath the live stream on YouTube. I haven't set this up as a Q&A hangout because they're more trouble than they're worth. So if you can ask your questions underneath the live stream, or if you have a complicated question, you just join. I've put the link to join the hangout underneath the live stream on YouTube, so you just need to click on that and you can come in. As I say, this is to answer people's questions. It's not to have a big debate. What I've tried to do is get some representation from various fields of science so that we can cover as many questions as possible. It's also possible that there will be questions that are asked where the answer is, we don't know. Because science doesn't know everything. There are questions out there that are completely unanswered. That doesn't mean that people are being...
They just lie without our area, outside our area of expertise.
So I think that's what we're going to try and do. Stick to our area of expertise. So if we just sort of wander along and decide what our areas of expertise are. I am a biologist, and I've specialised in bacterial physiology and also in molecular biology. Now, I'm just going to go along the bottom in the order I see the picture. So, Adam, what's your field?
Well, I am actually a patent attorney. My academic credentials are in physics and mathematics, but my primary expertise these days is applied physics and particularly mechanical and electrical engineering and computer science, mainly as it pertains to cutting edge technology.
Right, young Becky.
Hi. Well, as everybody knows, my real name is Jade, but my name on this thing is Becky. Young, I like that. I got a kick out of that. Okay, I'm not a scientist. I did study biology in college, and of course, chemistry and physics and all the stuff that went in it. I also took a marine technology program where I studied marine biology, oceanography, and all that stuff. I've worked in the computer industry for over 20 years and studied computers even before then. I actually go back to when the home computer was new to the bulletin board system era before we even had the internet. So I have some, like programming and software and even a little bit of hardware experience. But I kind of consider myself a talented amateur because I have continued my studies. I've got so many university course credits, it's absurd because I keep going back and taking stuff. And I love to watch lectures on various different subjects, and I don't just watch lectures, I actually go to university websites, find out what the textbooks in particular courses are, purchase those textbooks and go through them. So there are certainly big gaps in my knowledge when you don't actually have a directed line of study in a certain subject. You kind of miss some stuff. But
right, thank you for that. Dave.
Hello. Yes. Hello. For those who don't know, I'm a psychology student. I'm doing my master's in the cognitive and emotional obstacles to why people don't accept socio-scientific issues. So probably in this discussion it'll probably be why people don't accept evolution. So what cognitive and emotional reasons people provide.
So basically, we're your experiment.
I didn't want to say that, but
you're going to collect data.
Yeah, you're my sample. Sorry.
Yeah. Right, my next one along is Matt Hunt.
Yes, my expertise is in mathematics and physics. I did an undergraduate degree in mathematics, MSc from Oxford in geometry mathematical physics. Did a year of theoretical physics for PhD. Then went into industry, doing effectively applied physics there. Specialised in nonlinear physics and shock waves. I came out to do a PhD in fluid dynamics, and I'm now working in the mechanical engineering department doing milling modelling.
All right. Next is Nathaniel.
Hi. Well, I'm not a scientist. I did study some astronomy and physics in college, but I graduated with liberal arts in English and history, and I also studied some archaeology. But I too have been working in the computer field since a very long time. I was on the internet actually in 1984 when it was ARPANET. Because my father had an account for his the company he was working for. So I've been on the internet a very, very, very long time, and I also was in the press corps in Washington D.C. At the White House and at the State Department, etc. For many, many years for different organizations. So that's my area of expertise.
Next we've got Nikolai.
Oh, yes, hello. I don't really have that many impressive credentials, but I'm currently studying molecular biology, and I'm on my third year right now.
Cool. Next we have Sam.
Yes, I studied biology and computer science as an undergrad. Then I got my master's in biology, where my research specialized on certain aspects of gene expression and what determines where a gene starts. And currently I'm a PhD student in bioinformatics, where my current research is on early gene expression patterns in pre-implantation embryonic stem cells.
Oh, that sounds fascinating. Then we've got Tommy.
Hello. I'm not even going to try to follow that. I'm just an investigator. I guess I'm just an amateur hack investigator of science and evolution. I'm not an evolutionist, but I find the whole topic very it's very enthralling. I love reading about it, and so yes, I am a creationist.
And we've got Kevin.
Hi, I think I'm pretty sure I'm the youngest person in here. I've put about 4.5 years toward a bachelor's degree in computer science, though I haven't completed that degree yet. I also spent a year working for a bioinformatics facility / lab here, so I have a little bit of background in that as well, and I've sat in on several graduate classes in that area.
Right. Now, I'm just going to. We have a grand total of 9 viewers, and I think I'm one of them because I'm keeping an eye on the YouTube channel. I just want to make sure that if we get questions coming in underneath the live feed, that we see them. Right. Well, I'm really sorry, Tommy, but we've got your first question. We've got a first question. Science Q&A. Why are you here, Tommy?
Well, it's not off limits to creationists. I mean, you've got to have some sort of a voice for, or at least someone who can question from the other side, right? I mean, that's not fair to totally overload the forum with people from one side. So
Yeah,
at least I might not hang around for the whole time, but I would like to just kind of, if I could, participate a little bit.
Yeah.
And
Sounds good.
I respect your wishes. I'm not here to debate. I mean, I'll go along with the flow, and you guys can talk about what you want to talk about. If I have a question, I'll chime in.
Right, because that's the point of the Hangout is that if you've got questions, ask them, and we will
Yeah.
do our best to answer those questions. I mean, this is a case of anything from cosmology to molecular biology. And I think there'll be a lot of questions, basic science questions that come up time and time again, rather than that are part of the evolution versus creation debate.
I think that's definitely, I agree with that. I mean, I think a lot of the problem with the internet discussion is a lot of people just don't have the, you know, the basic foundation in terms of like just high school level, like Mendelian genetics. I think if more people understood that, then, you know, that would inform the discussion a lot. Yeah,
that's true. And that's something I've come across quite often, that where I will be asked a question, that the question itself just leaves me lost for words, because it's not a question that someone with any basic idea of science would ever have asked. You know, the question itself contains so many errors that you could spend a week trying to just work out the question before you answered it. So that really is a problem. I'd like to know what are the difficulties that scientists have in attempting to explain their science to lay people?
I think one of the big things is jargon, because science has its own set of jargon, and we're so familiar with using it ourselves. When you have to unpick that jargon into everyday language, then it becomes quite difficult. So I think that's one of the things that I think may be a barrier to explaining science to people who are untrained in science.
Mm-hmm.
I think there's also just a huge I mean, there's also, you know, in any field, you know, if I read a paper in my field, there are certain assumptions that are made about the audience. Like, you know, if I'm saying I'm measuring X this way, you know, oftentimes I have to stare at a paper sometimes for 5 minutes to be like, oh, that's what that figure is saying, because so much is assumed about how educated the audience is. So I think a lot of the times it's a failure on our part to explicitly make things accessible.
I think another problem is the opposite of jargon, of using commonly used words but in a different meaning. So, for example, if we talk about evolution, we think about, you know, fitness. It doesn't mean what we think. Well, it generally means, or even scientific words like theory. It's using words that we don't use. You know, strange, bizarre, usually Latin words. For example, in neuroscience, it's a different language. You know, it's alien to me, and I, you know, did a degree in psychology. But I think it's the twofold of words that no one, or, you know, a very selective few people understand and know and are familiar with, and then using words that everyone's familiar with but in a different way, like theory, you know, with adaptation, fitness in evolution, and I guess in other scientific ones as well. So it's that double-edged sword of precise language and then people thinking they're familiar with words that they're not in the scientific context.
Well, I actually had something to add to that. It's very interesting to me because a lot of people who would argue the definitions and what is in the papers, they seem to stick on evolution and astronomy, etc. But you never see somebody arguing against, let's say, the definitions and the findings of engineering. You don't see some people saying, you know, I reject the way we should build bridges. I'm going to build my own bridge with my own stress test values, and I'm going to drive my own truck over it, because, or I'm going to fix my engine this way because you know, the experts say one thing and I know it's different because I believe it's different. Because a lot of, or you know, even flying airplanes, you don't see people saying, well, I'm gonna you know, build my airplane this way and dive off a cliff because I think that engineering should be this way and not the way the experts say. and these things would have dire consequences to their lives.
Can I answer that? Can I answer that? The difference is.
Wait, Tommy, let him finish, please.
No.
I thought he was finished.
I've spoken to Tommy before. It's okay. It's all right.
I'm sorry. I thought he was finished.
No, go ahead. Go ahead.
I was just going to say the difference is the theory of evolution doesn't have a hard definition. I mean, if I ask you guys individually, when you're not in a group, to define the theory of evolution, I'd probably get 9 different definitions. And in fact, there's
I think.
Wait. Let's go with that. Just for a second.
There's a new paper out, just really hot off the press from Nature, and the title is called "Does Evolutionary Theory?" I'm paraphrasing. Let's see. It says, "Does evolutionary theory need a rethink?" And so you've got a pro and a con, and the problem is you've got half of the scientific community thinking that this thing that's passed off has been as the scientific theory of evolution for the past several decades. Is that really indicative of what happens in nature? And so you've got half the people who think it is and want to keep it, keep the theory going as it is, and then you've got another group that say, hey, look at all these things in nature that aren't jiving with what the theory says. So I've got the link down here. You guys can check it out at your will.
Okay. All right. Let me ask you about that.
Right, we've got some questions here. We've got some questions here coming in on our the first question I'd like to tackle. Can you please elaborate on how scientific knowledge is tentative and never proven the way it is in mathematics or logic? I'd like to take that one. It's because we look for evidence to support our theory. The problem is this, that you can have as many pieces of supporting evidence as you like, but one single piece of evidence which contradicts it is enough to throw out all those pieces of evidence. If you think of it as circumstantial evidence, you can have loads of lines of evidence that point to one person being the perpetrator. But if you have one solid piece which shows they could not have been the perpetrator, then the theory is knocked into a cocked hat. It's disproven. You can never prove it because you can never know that you have collected every possible piece of evidence that's out there. And that's why we always say that science is tentative, because we don't claim to have all of the evidence. We acknowledge that there may be evidence out there that we do not know anything about that may contradict our ideas. So we leave that door open. In other words, we're not arrogant enough to say, this is how it is and we are right, end of story, it is proved. Because we know there's so much more that we need to find out.
But the problem is there's some foundational premises, say with the theory of evolution, that are completely contradicted by the evidence. I'll just give you one real quick. The theory of evolution says that animals changed over time via changes in genes. Protein coding genes mutating, selection come along behind and adapting population. But, hang on, let me finish the sentence. But they're coming out now with the realization that there's much more to genetics or to heredity than just what's in the protein coding genes, that there's something else above the genes or apart from the genes that's carrying heritable information.
Let me stop you there, Tommy, please.
Let
me stop you there, Tommy.
Okay.
Because what you're doing is you're just confirming what I've just said.
Well, you can't have a theory that says animals change over time by changing protein coding genes and then come along and say, well, there's something else that's causing that.
That's not...
Tommy... What I have just said is that nothing in science is proven because we never say we have all of the evidence. Okay? And you are confirming that. You think you're arguing against the point I've made, but you're not. You're confirming it.
No, I'm not.
Tommy, I've just told you, science never says this is the answer, end of story. It will take on board new information. It will revise its ideas if it comes up against new information.
Let me put it a different way. The theory of evolution says only populations evolve, but if you have individuals coming up with new adaptive traits,
Tommy, we are talking about.
I can't get a sentence out. Hang on, let me just say the sentence.
No, Tommy, you're derailing already. The question was about the nature of science in general, and why we never say something is proven in science. And it's because we never assume we have all the evidence.
But I'm saying, if the evidence is contradicted, the question to begin with was why do they not seem to get a grasp on theories? And one person was talking about, comparing it to, I forgot what his comparison was, but whether it be physics or something. But that's why the general population has a hard time with this particular topic, is because it's so convoluted that no one, even scientists, know what the theory of evolution is.
Okay, so I need to speak because a lot of things have been said by Tommy that are A, factually incorrect, and B, just misunderstandings. So as the resident geneticist, so Darwin never wrote about a gene. He didn't understand inheritance. And the common view before the human genome was that really it was just the protein coding regions changing. Now, since ENCODE, we know that there's a whole other layer of sequence regulation, which is that the things, regions that help control and govern gene expression also can be selected for. That's a large portion of variance. There's also the fact that, because it's so regulated at multiple levels, these things evolve across populations in different ways. The reason why you don't get, and now to what the greater problem is, what he said, the reason why you don't get the same answer from every single scientist as to what evolution is because evolution in the context of different fields means different things. If you're a developmental biologist, it may mean the creation of a new developmental pathway across different species. If you're a population geneticist, that's going to be sort of the classic alleles frequencies change over time. But for a paleontologist that can't measure allele frequencies, they're just looking at the general change of the population over time. So I think it's a bit unfair the way that he seemed to treat this, and this is why you have to be tentative and careful about what you say, because terms don't mean the same thing in every.
Right. I think I just checked out underneath the video, and the person who asked the question, who is called Got Nothing Clever, says thank you very much. I think they're happy with that answer. That's their question answered. Now, Matt Hunt, you're on the spot. Are you there?
Yeah, I'm here.
Okay. Do black holes have entropy? That was Benaberry that asked that.
Yes. But it's a different type of entropy from the normal classical thermodynamic entropy. They define entropy in terms of the surface gravity and the surface area of a black hole. Bearing in mind that these definitions come from the mathematical definition of what a black hole is. So we may not be able to measure the surface area of a black hole, but we can certainly theoretically say this is the definite area of a black hole. It's just the surface area of the event horizon. And people have said that if you equate these surface gravity and surface area of the event horizon, you could define entropy, and then you've got heat associated with the black hole. So you've got an equivalent law of thermodynamics for black holes in terms of surface area and surface gravity. So yes, and so black holes do have entropy, and there's been a whole new idea, which I think is quite exciting, about the question of do black holes exist? and this is all to do with the event horizon, because if we take for example, just take a stationary black hole, then when you do the mathematics, you'll find that it has a singularity at r equals 0, which is the real physical singularity, and also a singularity at r equals 2m, where r is the radius and m is the mass of the black hole, and that's the actual where the event horizon is. And so what you can do is you can do some mathematical trickery and do a coordinate transformation to get rid of this singularity, the event horizon. So then you can just say, well, you define the black hole via the event horizon, but now you have no event horizon because there is no singularity. So the question is, do black holes exist? And that's also an interesting question from the mathematical point of view, and also from the physics point of view.
Well, I'm hoping that answers Ben Aberry's question. If you could just reply underneath if that has answered his question, because I can't tell, given that I know diddly about black holes. Let's see if we've got another question. There was one I saw. Yes. Why do you guys think so many people, religious views aside, are so disinterested and incurious about science? And someone has suggested that it may be because it's the difficulty of it. If you can't grasp maths, then you're going to be struggling with science. I myself think a lot of it has to do with science education in schools. And it can be seen as quite a dry subject. And once you lose track that early on in science, it can be very difficult to then sort of catch back up and be able to understand it. But that would be an interesting question for the rest of you. Why is the public so disinterested in science?
Part of the reason, I think, in some cases, definitely not all, but with some people, especially some of the religious ones, as the quick commenter mentioned, is I think some people are definitely afraid of science, afraid of knowledge, because it has the potential to challenge some of what they might hold to be true about the world. They might have being educated about anything means questioning your own preconceptions and preconceived notions and biases, and I think that is something that scares a lot of people.
Yeah, we have a history of anti-intellectualism in this country that goes back a long way, and I think, I haven't investigated it myself thoroughly.
I can't hear.
Yeah, Becky, you're breaking up really badly.
Oh, sorry. Okay, let me try to fix it. Can you hear me now?
Yeah.
Yeah.
Okay, I just have to watch that microphone. So I was going to say we have a history of anti-intellectualism in this country that goes back quite a long way, and especially in the 1800s. And it has a lot to do with the people who came here and felt that, well, we're just as good as anyone else, so how can you be telling us this stuff? We should be able to understand it. And there's a real reluctance to accept the authority of anyone, whether it's in political science, whether it's in economics, whether it's in science. There's almost a fear of knowledge, as if you're not better than me, sort of thing. Just because you've studied science doesn't mean you're better than me. Well, just because someone knows something doesn't mean they're better than somebody else. I'm nearly completely ignorant about physics, and I'm really, really lost in the realm of social sciences. And yet I'm fully happy to accept Dr. Hunt's authority in the area of physics, and so many other people in the areas of sciences, the fact that I am ignorant of many, many, many things does not threaten me. But I do think it threatens other people, as if they feel they're somehow inferior.
Well, again, to go back to the car analogy, nobody's threatened by cars, even though most people don't understand exactly how they work, and most people can't fix them or build a car from scratch, but it doesn't threaten their worldview. And so they don't really, it's not a challenge to them, and they don't have to challenge it back. You know, but there are rather disingenuous fights against certain things in science which have been proven to work, at least, and the models work, and we use them every day in life. We use relativity every single day. If we have a cell phone with GPS, we're using the theory of relativity. You cannot get GPS to work without relativity, and yet some people would deny it, even though they're using it every single day. The same with computers. You know, we're using more and more. We're starting to use quantum computing, etc. People really have no idea what quantum physics is about. I mean, 99.9% of the population really couldn't tell you anything about quantum physics. They know at most what Deepak Chopra would tell them, which is absolutely wrong. So there's a lack of understanding on these things, even though they tend to use them every day. And if it challenges their worldview to accept them, they tend to mistrust it, and that's really all there is to it. You know, but once again, you don't have anybody challenging aerodynamics. And we fly every day, but aerodynamics doesn't really challenge their you know, worldview. If it said something in their religion that that flying is impossible, perhaps they would. But you know, I don't know about that. But it's pretty clear that there are differences there.
Nathaniel, what we have with things like aerodynamics and things like the Great Flood is they're both modeled by the same set of equations.
Mm-hmm.
So you're right, aerodynamics is very uncontroversial, but if you look at what the Walthams have done in the flood, for example, then it goes totally against the equations that we know about. So that's so in one way they're accepting fluid dynamics in one area, but rejecting it in another area. So
yeah, I would agree, absolutely agree, because one area challenges them and the other area doesn't. So they have this cognitive dissonance going on, and if you get right down to it, it doesn't make any scientific sense. But it's you know, you know, I'm not defending that point of view either.
I guess to throw a bit of psychology in here, if anyone's interested in some terminology to look up for some further reading, the two sort of main theories or perspectives, or whatever you want to call it, is the social identity theory and the cultural cognition theory. Basically, it's the individual and the group. So, cultural cognition is basically that we form beliefs about sort of societal dangers or perceived societal dangers, which is based on our own sort of our own view and our group's view, because we don't want to rock the boat, and because we have a personal view. I don't want to accept X because it violates my perception of reality. And then the social identity theory is, again, it's a similar sort of thing of, I have this view. For example, if I was a Christian, I think the Bible is literally true. Anything that contradicts that, I shall reject because it's my social identity, it's my perspective, it's my view, it's my ideology. So these are the sort of big sort of hitters when it comes to why people don't accept sort of certain things. People mentioned in the chat things like GM crops and cloning, stem cells, climate change, these massive, you know, socio-scientific issues that, you know, particularly in America, less so here in Britain, are so politicized. And I think the problem is people don't understand the difference between a social, you know, political controversy and a scientific one. For example, you know, 95% of scientists agree with climate change. You know, 99% agree with evolution, and so on and so on and so on. But you know, 50%, less than 50% accept, you know, climate change and evolution. So this is partly the reason why I'm doing the masters I am, and hopefully the PhD that I'll be doing, because these are big issues. You know, when you say, we're going to stop medicine, or we're going to do, you know, cloning and stem cells, would be too, particularly stem cells, would be too instrumental, you know. And same thing with 3D printing of organs. These would be incredibly, you know, giant steps forward in medicine. But because of people's ideologies saying, no, we can't accept that because human life is sacred, or only God can take life, and so on and so on and so on. So this is, you know, a massive issue, and
I agree, and I'm actually very interested in what you're studying.
Thank you.
I just have to say that because
Me
it's true. Yeah, no, it's true. I was wondering if I've ever going to meet somebody studying that particular issue, because it has been, you know, as you know, a fairly contentious issue in the last 20-some years in the media and in society, especially in America. So I was just curious what somebody who's studying that thinks about all of it.
It's quite, I was gonna say depressing. I mean, I'm in Britain, so I think we're quite lucky here that they aren't politicized issues, or at least not as much. But in America, and it's amazing that the Times University, the Times Guide to University, so it's like the 10 most powerful university brands probably, and the top 10 were comprised of British and American universities, and yet there's a fundamental disconnect. For example, I'll go back to evolution because that's something I know a bit more about. 93% of people in Britain accept evolution. It's about 50 accept some sort of evolution in the US, with about well, probably the majority accepting sort of theistic evolution. When you compare them, and they both have the most prestigious, most sort of powerful universities, it is strange how there is this disconnect between these sort of socio-political issues. That Britain, it's a secular country, it's one that sort of does follow science, it does try and promote science, it has, but then you go across the pond and then it's so strange, because that should be secular. It has, you know, the secular roots, whereas Britain
and it's written in the Constitution, whereas in Britain it's not. I mean, I understand the dichotomy there.
So I could talk about this all day, but I don't want to hog everything. So if there's another,
I find it to be interesting because it's kind of a lot of what we're talking about, I suppose.
I mean, I have to do my research because I'm right now I'm testing a hypothesis using publicly deposited data, and I'm doing some of it in human embryonic stem cells, and all the data I'm using for human embryonic stem cells is from China. It's not from the U.S. because no one's going to fund that, which is unfortunate. You know, not that, you know, labs in China can't do stuff, but it's unfortunate that it's being hindered because there are, you know, obviously brilliant developmental biologists everywhere, and why should one country be hamstrung in that area of research? Because when you read about it, you know, this idea that you know, you're evilly killing a baby is just not at all reflected into what the procedure is of getting these early pre-implantation embryos.
Wait, have you ever heard Sam Harris talk about the subject, that when you're swatting a fly, you're destroying, I think it's 10 times more brain cells in a fly than you have cells in a stem cell embryo. So
well, I mean, there's the issue also is that it's completely arbitrary that we choose these cells to kill, because we can induce an embryonic stem cell like state. It's not exact, but we can induce what's called pluripotency, which means that it can become basically anything, with some exceptions. I could go into that. That's not that important. But the important part is we can induce that. And also in mice, we found through a certain type of test that you can actually incorporate that. You can replace the normal cells in the mice with these induced cells, and you can still get a functional embryo. Granted, not the same percentage of the time, but there's really no molecular difference between taking it's just what the gene expression pattern is. There's nothing magical about a stem cell that is precluded from any other cell. So, I mean, I think that if you like to exfoliate, then you're doing as much damage to the potential souls of your skin cells, which are commonly used for creating these cells, that you would be to, an embryonic stem cell.
Yeah. I agree. I do have one question though, and this I don't know how it would be answered, but that's why I'm asking. You're aware that I think it was 2 years ago or so that we created the first artificial, I think, proteins or something. My question is, if we could actually create artificial stem cells, let's say 5-10 years in the future, do you think that fundamentalists would be opposed to using them in experiments, even though they're artificial?
I mean, they're not opposed. That's the funny thing, right? I have my own ideas and posturings about why they have an issue, but they have no issue with induced pluripotency, and all that is just using a retrovirus to cause the genes to cause the cell, to express genes that will cause it to revert to being a stem cell. They have no problem with that.
The argument from the beginning is that we can learn through research everything we need to from adult somatic stem cells, and there's no need to go to embryonic stem cells. So I would assume, since for the same reason they have no problem with the use of adult somatic stem cells, they wouldn't have a use with fully artificial, or they wouldn't have a problem with fully artificial stem cells either. It really is an outgrowth of the. I mean, it's all an outgrowth of the pro-life position. It's all an outgrowth of concern over the zygote, over the embryo. And so you get away from that, and you're getting away from the area where these people have ethical issues with the research.
But if it was an artificial zygote, then what then?
Oh, you mean so you're going to create an artificial cell that if implanted would grow into an adult human?
Absolutely. Yeah. Let's.
No, I would expect they would probably have an issue with that. With creating that. I mean, it seems like it would be pretty stupid to go out of your way to create something specifically designed to implant and grow and then kill it.
I'm just curious about the ethical stance that they would take. Is on.
I think they guys. I know this is interesting, but we've got some questions that we need to tackle. I've got one. Now, I'm not really quite sure what the question is asking. It's from Brandon Bellinger, and it's, why are the atheist extremists? I think the question is, why are scientists atheist extremists?
I think that's a troll comment.
Yeah.
And I would point out that not all scientists are even atheists, let alone atheist extremists. So therefore I can't answer that question, because it is based on basically an egregious...
It's a loaded question.
Exactly. Well, it's more than just loaded, it's just a wrong question.
Yeah.
And the only thing you can say is science uses methodological naturalism. So, by definition, you can't assume that any cause for anything is necessarily supernatural.
But that is a biased and extreme position, because it could very well be that this existence is supernatural and or caused by consciousness.
The thing is, you can't test it.
You're automatically eliminating a priori that possibility. So that's why, getting back, you're asking why people are anti-science. That's why, is because by definition, you rule out the supernatural as a possible cause for anything.
No, you don't.
Tommy, let me tell you this, Tommy. Let me tell you this, Tommy. If you can design and build me a woo detector, then I will happily carry out the experimentation to detect woo happening. I can then work out how many kilowoo something
I could ask the same thing about your chance-based origins, your dumb luck origins. You can't do that either.
Until you give us a method by which we can examine the supernatural, we are unable to examine it.
I can say the same thing about your chance-based origins. The origins of everything. I don't know why you guys say that.
Tommy,
hang on, let me finish. Why do you say that God is a science
Tommy, this is my hangout. You don't tell me to just let you finish. The point is this. We can't test the supernatural.
You can't
That's
test
why
chance either.
You can't test chance.
No, you can't.
Absolutely, we can test
No, you
chance.
can't.
There's only
Yes,
one.
you can.
Tommy.
You cannot test
Tommy.
chance from the past.
Strike one.
Tommy.
The point is this. You are declaring that it's all just chance. There's a
No,
problem.
I'm not. I don't believe that at all.
Strike two, Tommy. The problem is this, that you are just declaring that the whole thing is down to chance, and you're actually forgetting one of the main planks, which is natural selection. Selection is not chance. And that is where your problem is. But the point I am making is that we cannot detect the supernatural. We can't look at a system in a laboratory and detect the supernatural in it. We admit that as a limitation.
You can't detect chance in it either. Chance is no more scientific than intelligence or consciousness or the supernatural is. So you're in the same. Tommy.
If I
Stop talking, Tommy.
if I could interject for
You hold on a bit, Matt, please. Tommy, you need to stop interrupting me. What I am telling you is science admits its own limitation, that it can only study the natural. It has no ways, means, mechanisms, equipment, anything that it can use to study the supernatural. So therefore, it bars itself from trying to answer a question about the supernatural because it can't. It cannot test any hypothesis that it formulates if the hypothesis contains a supernatural element. So on the question of the supernatural, science remains neutral. It doesn't enter into that because it can't, and it admits that it can't.
But it goes further than that.
Its own. No, that is it.
No,
Science
because it also
cannot do
science also does not investigate intelligence. They don't investigate consciousness.
They
They
don't
don't investigate mind.
investigate.
So
They are anti-ID at every level. They don't investigate ID at all, whether it be evolution.
Tommy, let's say I grant what you say, that everyone is anti-D. What hypothesis would I actually do to test it? Because as a scientist, the thing that I find, you can debate and flap your gums all day long about, the scientists are conspiring against ID, but ultimately, if you don't, most scientists that I've known aren't terribly hard-headed to a left-of-field idea if you can actually test it, you can actually go and, well, then why should we even be having this discussion in the context of science?
You absolutely can test it if I can finish. If you're going to test evolution, and I mean that by change over time in animals, all you'd have to do is to test an individual, to test its intelligence, is to put it in a stressful situation, a challenging situation.
That's not evolution, that's learning.
Yeah, that's
if the individual could come up with its own adaptive trait and pass it on to future generations. That would be a test that would test intelligence or consciousness or some sort of a internal capacity.
Why would that test intelligence? When we look at
actually, I'd like to say this is Tommy. He's not actually talking about testing intelligence. This is Tommy's pet theory that an experience within your lifetime can cause your offspring to adapt to better survive that experience.
It's not even controversial. It happens all over.
So this is very related to what I study, and Tommy, you just don't. I hate to say it because I've said this 1,000 times, and I'm repeating myself. You just don't understand how epigenetics works. And
it doesn't.
And I've had
You keep saying that, but I don't have to understand what it is.
Let me finish the sentence, Tommy. So right, there was a study, I forget, it was in one of the Nordic countries, I think it was Sweden, where they saw that, when there was a famine, they were able to show that there were heritable changes in the, next generation. from the generation that endured this famine that led to them being more predisposed to things like diabetes and various metabolic disorders. And so when we look at how those things change without a visible change in the genome, it's because these certain chemical markers get modified. However, when you look at other traits, epigenetically, they don't vary. What epigenetics just means is it's the inheritance that happens without a change to the actual genetics. So they're stably inherited without the change in genetics. So yes, there are changes that happen, but they're fairly, we don't know the extent to which they happen, and there are actually labs out there. There's a lab at my university that published a paper in Nature about this that actually looked at this variation as if it was, mutations in the traditional genetics forms, and they just saw that, well, one of the reasons that we can't discount this is because there's more variation in terms of if you treat them like epigenetic marks like mutations, well, then you can say, oh, this is just another way that a population can evolve because it behaves very much like genetics.
No, it doesn't, because the difference is
okay.
these epigenetic marks. Okay, I'll let you finish. Can I finish? Can I just finish one sentence?
Sure.
It's different because the epigenetic marks don't just happen haphazardly. It's not a chance-based thing. Just like this little link I gave you over here, it says frightened birds grow longer wings, or the offspring do. And so what happens is the mother experiences a new environment, and then somehow the right trait emerges at the right time within the offspring. So this is not chance-based, which is what the theory of evolution says.
Okay, so let's look at that, right? When it's epigenetic, it's a change to the chemical modification on the DNA. It's a completely chemical process.
So what's the difference if to change at the right time?
I mean, it's just a modification. There's
no. What causes the right trait to emerge at the right time?
Because the environment changes the chemical environment in the cells of the parent.
So how does the environment do it? Does it just reach down in there with its hands? How does the
environment?
Okay, sorry. Excuse me, Tommy.
Yes, I'm just asking a question.
Tommy, I'm not having you doing that. I'm really not having you doing that. And
I'm just asking a question.
Like that. No, the environment just reaches down. You know exactly what you're doing that question.
I'm asking how the internal environment knows what the external environment is.
Tommy, can I give an example?
Nope, sorry. Tommy has been ejected because the question that this all started off on, I have lost track of, and I'm just not going to be having Tommy doing his usual. That's not what this is about. This is for people to come in and ask questions about basic science. And I'm not going to have Tommy saying, oh, how does the environment do that? Does it just reach down? He knows that is not what anybody is saying.
He is a troll.
Exactly. He is a troll.
He said himself in the chat that he doesn't trust scientists anyway, so I don't know.
Yeah, I know that. I know. And I mean, I gave him a chance. I really gave him a chance.
Yeah.
And
we address Gary's question.
He will now claim to be booted out because we couldn't answer his questions. No, I'm on record. Tommy, you were booted out for being a troll. You weren't actually interested in any answers that you were going to get.
All Tommy did was every time somebody answered him, he'd go, but,
yes,
and change the goalpost, move to something else, and say silly things.
I'm not going to have this hangout derailed like that. I'm away to check out.
I wanted to ask Gary's question.
On you go.
Okay, so Gary, Phony Beetlemaniacs, is really trying to learn about biology and understand evolution more. And we all know that, as a fact, evolution is a change in allele frequency over time. What Gary wants to know is, what is an allele? Can you explain it? And can we talk about just exactly how this process works to change an allele frequency over time? Giving examples. I think most people here can do it, so who wants to take it?
Yeah. I'm having a look to see what other queues. We've got... Somebody has asked, nature versus nurture regarding the psyche. Which has the stronger influence? That's from Benaberry.
Yeah, I mean, we can do either of those. I really like talking about nature versus nurture because more that I like actually like expressing the ideas to people, because most people don't actually know, what the actual dialogue is about nature versus nurture amongst, people who are looking at it, because it's dynamically changing at the moment, which I think is cool.
Can we address Gary's question first? I think he's been waiting for a while.
Oh,
Yeah.
Sorry.
What an allele is?
And how allele frequency over time works.
Oh, yes, sorry, I lost track. So I do apologise, Gary.
My understanding of what an allele is that it, when you have, genes have different variants, right? So let's say that I inherit a sequence from my mother that, predisposes me to baldness, let's say. And then I inherit that same sequence from my father, because, of course, we inherit half of our sequences from our mother and half from our father, and they're almost just mirror images of each other, with obvious exceptions being the different chromosomes with X and Y if you're a male. But an allele would be that sequence, whichever variant, whether it's the baldness variant or the not baldness variant. And this is, the way that this leads to changing over time is because these variants impact, how what the organism expresses. So whatever trait, and let's say there's a selective pressure for baldness, then my mother's variant, which would make me more bald, is likely to become, under natural selection, is likely to become more, more abundant, because of the fact that it will lead to more survival and reproduction for me.
I hope that helps. A question here. I'm trying to get the physics ones in at the front, because I know Matt Hunt wants to get to his bed. Are you still there, Mr. Hunt? Sorry, Dr. Hunt?
Yeah.
He gave a thumbs up.
He's here.
Right. The question is, how do you think the discoveries at the LHC will change science, and what new potential fields of science may this open the way for?
Well, I guess on a practical level that we have now, it won't change science at all. It'll only change bleeding edge science. So the stuff which we thought was theoretical now becomes practical, or experimental at least, and so they'll change the models we use there. And I think the more we do experiments like this, the more we have to push technology as well. And so that will give new ideas for things like high superconducting and all this sort of stuff. So it'll make impacts there, but I don't think it'll change what's in the textbooks just yet. But it will certainly get theoreticians thinking potentially on different lines than they do now.
I can say that just from my point of view, the discoveries at the LHC, for me, mean I get to see more of Brian Cox.
Yes, I agree. I absolutely agree.
I am a big fan of Brian Cox.
You follow him on Twitter. He's really interesting on Twitter too, actually.
Yes, I do follow him on Twitter, but that's not why I'm so pleased that I'm seeing more of Brian Cox.
Yeah, no,
I have to say,
I understand.
I have to say, as a straight male, that guy has a sexy voice.
Yeah, yeah.
And he's always smiling. He never has a straight face. It's
I
just
know.
constantly this lovely smile. I was heartbroken when I found out he was married. My husband took great delight in telling me.
That's funny. Poor Fiona.
Can
I
I add something to the LHC answer?
Yep.
If I could. And I'd really like to do it while Matt's here so he can correct me if I've got it wrong. But I think to get into something more specific that the questioner might be interested in understanding if he or she doesn't. One of our big problems in physics is that we have two really good models, one for gravity and big things, and one for quantum mechanics and small things. And the problem is that we don't yet understand how those two different models interact together. Quantum gravity is something that is still very much a matter of hypothesis, and we're missing out a lot on. You've probably heard that the LHC found the Higgs boson, and one of the important reasons we were looking for the Higgs boson was because the Higgs boson, if it existed, and it turns out that it does, tells us something about a quantum particle that deals with the mass of objects. And so, by the way, the reason we've had so much trouble with figuring out gravity at the quantum level is because gravity, relative to the other forces, is really weak. Gravity really only comes into a play in a way that we readily observe on a very large scale when we're talking about planets and galaxies and things orbiting each other. Basically, the other forces relative to gravity are so much stronger on the microscopic scale that it's impossible. You can't measure gravitational forces in a particle collider, or sort of any of the technology we currently have. So the LHC was when we built it, we were really hoping that we would start to see some of these particles that deal with quantum gravity, and maybe this will be the next step towards reconciling that particular problem. Matt, was any of that grossly wrong?
No, not grossly wrong. But we do have two. I won't call them theories. I'll call them models.
Models. Yeah.
There's loop quantum gravity, which tries to combine quantum theory and general relativity. That's reasonably successful and is being pursued by some very good people. And then there's M theory, which has no real experimental evidence at all. But the way to check quantum gravity is with things like black holes, because there you have quantum effects as well as very strong gravitational fields. So I think we may be doing quantum gravity with astronomy rather than the particle colliders.
Can I take that question further, Matt?
Yeah, sure.
It is a question for you when you spoke about black holes. Do we live in a black hole, or could we possibly be living in one?
I don't think so.
That's an interesting question.
No.
I've heard that theory before, though.
It's what I'm going to conjecture. The inside space of a black hole has certain things, certain characteristics, and I don't think that we see those characteristics in the space around us. So I don't think we live in a black hole.
Sorry, I'm just checking out questions. See if we get any more. Now, let me see. Let me see.
I have a long question for Matt, but maybe it's for when there aren't any questions left.
Go for it.
Yeah, go for it.
All right. All right. As I mentioned, a lot of people, almost nobody understands quantum physics. So I'm wondering if you could explain in layman's terms quantum entanglement for people.
It's beyond my level of quantum physics and understanding. Yeah, I would need to go away and read up about it. My knowledge of quantum mechanics is patchy at best because my undergraduate degree was in maths, and I've done a basic course in quantum mechanics, but that was very, very much on the mathematical aspect. It was basically mathematical physics. So we defined the axioms of quantum mechanics as a set of mathematical axioms and just did the maths for it and said, here's an atom, this is what you do. So my understanding of quantum mechanics is somewhat limited, but I have been reading around this subject, so I understand.
And there we have it.
Yeah.
Thank you. No. I'd like to thank you for proving that scientists are not arrogant people, unlike what creationists state they are. Because a scientist would never delve into something he has no expertise on and try to pretend that he is actually an expert.
Well, of course, quantum
which is what Tommy was doing all along. He has no expertise. He has no degree in these subjects, and yet he sits there trying to tell people like Fiona, trying to tell people like you, Matt, what science is and isn't, and how it should obey his idea of physical laws, and he has no concept.
He even admitted, like at the beginning of the Hangout, that he was a hack.
Yeah. So that to me, thank you, Matt, for demonstrating the honesty, the integrity of scientists and science in general.
I would be willing to tackle the issue of quantum entanglement just because I think I've done layman's reading on it more recently than Matt. I expect my deep mathematical understanding isn't any better than Matt's, but I'd be willing to give it a shot.
Go for it. I'm curious. I'm interested.
So
let me. I'm going to have to go now. So it's been nice chatting to you, and hope you can do this again.
Yeah. By the way, Matt, I would count it as a personal favor if you would perhaps watch this Hangout later and write me if anything that I say is inaccurate.
Okay. I'll see what I can do. Okay.
Have a good night, Matt.
You take care, Matt, and thank you very much for coming along.
Okay. No worries.
Thank you for answering my question.
Yeah. Take care.
Somebody's actually asked a question about the proton waterfall. And I have to admit that this is something that I would need to actually look into this a bit more before I would even attempt to answer the question.
Do you still want me to tackle the quantum entanglement question or not?
Yeah, go on.
Yeah,
okay.
Yeah.
So here's let me start with a real quick analogy. Okay, let's say that we take a billiards table, and we decide what we're going to do is we right over the billiards table there's no light source. We can't see the balls. Okay, when they're in the middle of the table, and you and I are going to throw two balls right at each other. Okay. It's quite possible that we could be in a situation where, based on what we know of conservation of momentum, the result of that is going to be that one ball is going the balls are going to bounce off each other. One's going to go to the left and one's going to go to the right. Okay, but we can't know ahead of time which ball is going to go which way. Right. But what that means is if somehow the balls traveled, we allowed the balls to both travel a really long distance, and then later we identified that one of the balls had gone really far to the left, we would immediately know that the other ball had gone really far to the right. You with me so far?
Mm-hmm. Yep.
Okay. So the basis of quantum entanglement is this exact same situation. So what you do is you take two particles and you interact them in such a way that the result needs to be that one of them is spin up and one of them is spin down, for example. It could be plus 1/2 and minus 1/2 or various variables. Okay, and here's the thing: because of the uncertainty introduced by quantum mechanics is such that after the experiment happens, each of the particles is actually in a superposition of states, spin up and spin down. Okay, the particle is not actually either spin up and spin down, and we don't know. It's literally in a. I mean, this is the basis. Or this is sort of the basic non-intuition of quantum mechanics, is the fact that particles objects are not in a specific state until they're measured. So each particle is either spin up or spin down. Still with me?
Yeah.
Okay. What quantum entanglement is the idea that after interacting the particles, each of them is in this superimposed state. You can move one of the particles far away from the other without it ever interacting with anything, so it's now really far away. And the idea of quantum entanglement is that if you measure one particle and it is either spin up or spin down, then the other particle immediately reflects the opposite value, spin down or spin up. Mm-hmm. Because the quantum state of the particles is entangled. Mm-hmm. Okay. So that's the basic phenomenon that we're talking about here. Quantum entanglement happens when two or more particles interact in such a way that the quantum state of one, which is uncertain, is entangled with the quantum state of the other, and resolving the quantum state of one collapses the quantum state of the other. Mm-hmm. Does that make sense?
Oh yeah, no, I've read actually a lot about quantum entanglement. I was just curious what Matt would say, but I appreciate your explanation as well, actually.
Sure. So probably nothing I've said is anything that you didn't already understand.
Yeah, no, I know a bit about it.
Okay. The big
but
question
mostly from layman-written books, so yeah.
Yeah, I mean the big question that always comes up is there any way to use this to transfer information? Yeah. And there are a couple reasons why we believe that's not the case, but the big one has to do with the fact that there are bits of information and there are qubits of information. There's real information and quantum information, and it turns out the two don't map. They're orthogonal, so you can never resolve a qubit into a bit of information.
Yeah, I could speak to that a little bit. I've done a little research on quantum computing. You can actually use there's a protocol called quantum teleportation that allows you to send qubits using an entangled pair, but you cannot send. There's no way to send classical bits of information. So no, you can't actually exploit quantum entanglement to get faster than light communication out of it. We'd love to be able to do that. That would literally change the world, but it doesn't appear to be possible.
Right. Right. Well, thanks. I appreciate your answer. I was just curious what other people would say about it.
All right. There was a question, and I've lost it.
Proton waterfall.
Oh, the proton waterfall.
I can't answer the proton waterfall question. I'd need to look into it.
I could give a sketch of what happens.
Yeah, go on.
Benneberry's asking about abiogenesis and what the proton waterfall has to do with that.
I don't know that it necessarily has anything to do with that, but basically the reason why you need oxygen is because at the end of the Krebs cycle, which is the cycle that produces the majority of ATP in our cells, which is like cellular energy, at the end you need hydrogen and oxygen to bind. And you need, and this is where I'm not, or you need to ionize the oxygen, which means that you just need to make it so that it is easier, so that it's not in its molecular form, but it more closer to its atomic form. And I believe the ion that you're getting is just O. 2 minus, but I would need to look it up. But basically, what you need to have happen is you need to have an electron be transferred to this oxygen, and as part of a series of chemical reactions, what ends up happening at the end of it is there's this proton gradient, which is the proton waterfall you're talking about. And basically, if I could draw it out, is you have all of these protons that are all layered and arranged in such a way that it guides an electron down to hit that oxygen so that it can react with the hydrogen, and then you can complete the chemical reaction that creates a ton of cellular energy, ATP. I don't know what that would be in the context. And again, this is a really broad sketch. It's not my area of expertise by any means, but I don't know what it would have to do with abiogenesis, but basically it's just an example of how cell biology uses, just hijacks natural processes like things going across gradients based upon chemical attraction and repulsion in order to get a chemical reaction to go through. I don't know how much sense that made.
Brian Cox has been talking about it, which is probably why it's at the top of people's minds. And it's trying to explain how you end up with energy. So it's something I would need to look into. I think it's just along the lines of proton motive force, but without cells. But as I say, I don't know a lot about it. It's something I would need to look into. Now, I'm trying to see if there's any other questions that people have. Yeah, somebody's asked a question. Quantum computing, does it have the potential to push AI to a human level? It's a question for Kevin.
Okay, as far as AI is concerned, my intuition, based on what I know about quantum computing, would be no. Really, what quantum computing will do is it gives us ways of solving certain classes of computational problems much, much faster than a classical computer would. And those specifically are factoring, searching, and there are a few others, but it's so for certain things. Oh, and of course, the obvious one is simulating quantum systems, which it can do. I mean, that's sort of what a quantum computer could do in its sleep. So for things like research into material science or protein folding, drug discovery, yeah, quantum computing could be a big advance. So if we're talking about stimulating the brain itself or stimulating an actual organism, I'd say yeah, probably, but just pure AI itself, I don't think the advance would be quite as substantial.
Google just did a massive investment in qubit in quantum computing technology. Actually, massive. They are banking quite a lot on it revolutionizing their algorithm, their search algorithms, and what they can do in the future. But so if you base AI on some sort of algorithm with searchable capabilities in terms of searching an answer, yeah, then yes.
It would help AIs in certain ways. It would help a lot of things in certain ways, but across the board, like it's not necessarily like a magic.
Yeah.
Some people.
The difficulty with that question is we don't know yet what simulated AI code would look like. I mean, we don't know the direction to take it yet. We're still researching how to create an AI sort of responsive program, and so it's hard to tell exactly how a new level of computing could help in a specific certain area when it's
Guys,
not
can I
developed yet.
just say something please for a minute? I'm going to have to just nip off for 5 minutes. Just carry on without me, quite happily. I'm unplugging my headphones, so I'll be muting the mic. But that means I can hear what you're saying. Now, the rule of any of my hangouts are this: if I need to nip off for any length of time, if anybody misbehaves while I'm away, they get put on the naughty step.
Oh yeah.
And then they get spanked.
Yeah.
Oh no.
Okay. It's
Well,
just
she still owes me a spanking from almost a year ago, I believe. So.
the problem is that my cat has just shit on the carpet, so I'm going to clean it up.
God. Right.
I wanted to add to that.
The one thing I was going to say is there's a common misconception that a lot of people have about quantum computers that's unfortunately been reinforced in some of the popular press, that it's equivalent to what's called parallelism, that a quantum computer will allow you to check like all of the possible answers to a problem simultaneously.
Yeah.
And that's not actually true. It only, for certain types of problems, the effects of quantum entanglement can sort of be exploited in such a way that you can arrive at the answer to much easier. Factoring is the classic example.
And I think also, like, just to chime in, I think we also need to be careful. What the mainstream conception of what AI is not necessarily what we're talking about here, because AI just is more of a broad field that allows us to use sort of these ideas of, machine learning and various different sort of tricks that humans naturally do, and exploiting them on a statistical level to, sort of train machines to optimize problems. And the jury's out as to whether, the quantum mechanics is a major component of how the human mind functions. My suspicion is it isn't, but what quantum computing will allow us to do, rather than solving that particular problem, is just allow us to solve a lot of different problems much quicker, which obviously is going to have a benefit on any sort of statistical learning model.
Yeah, there's a lot of branches in AI, and once again, we don't know what real artificial intelligence would look like. I mean, people used to think it's the Turing test, but people have actually created programs at this point which can sort of pass the Turing test by now, given within certain limitations. And so it's really up in the air as to what AI would look like, and because you have to think, what does AI mean? Does it mean sentience? Does it mean just programmed code that can respond to almost any circumstance as if it's a person? And if that's the case, does it qualify as an intelligence? So there's still a lot to be worked out there. I mean, it is really on a very fundamental level, it's a complete unknown still. But I would say, I would say that quantum computing, in terms of algorithms, is a wonderful thing, and if AI is going to include some very extremely complicated algorithms to determine, responses to certain situations, then yes, it'll help, but that's not all AI is. So it may be a piece of the puzzle, but it's not the actual end result.
Yeah, and especially because a lot of what goes on in the brain, especially in just these really complex gene expression patterns, we don't know all of them yet. And the nice thing that quantum computing would do is it allow us to simulate those networks just so much faster. But again, there's a difference between. I want to be careful because people always sort of misstate what AI is. And this doesn't mean that the brain is somehow magically quantum. We just don't really know like what's going on in there.
I think people basically think of, you know, the equivalent of like Lieutenant Commander Data or something as their artificial intelligence, you know, comparison. But that's a very, very long time away. I think it will happen. I have no doubt that computers will achieve, in a sense, sentience. I think it's inevitable one day. Whether or not we're going to live to see it is really, who can tell? But it is definitely in the cards. It's just a very long time away. You know, but
I think we'll definitely see scalable quantum computers in our lifetime, at least before we see human level AI. We might see both, but I think quantum computing will come first because we already know how they work. We already know it's possible. It's just an engineering problem at this point.
Well, I would posit that it's probably going to be the case. I mean, this is a wild speculation, but it's probably going to be the case that we would much easier achieve AI with genetic engineering of a semi-biological brain with nanotechnology that before we would ever create a microchip that could do it. So the answer to AI really would be at least half biological in my view. You know, on some sort of biochemistry level. It just is not going to happen with silicon, I don't think.
Well, I mean, network reconstruction from like a biological engineering point of view is not only possible, but it's already happening in industry. So
right.
I think that intuition is definitely, at least for me, somewhat in agreement with that. You know, a lot of it's just unknown. The work's got to get done. You know.
Yeah, exactly. And it's unknown, and it will be unknown for quite a while yet because we have so much work to do in so many areas still. I agree. Yeah, you know, it's the problem with singularity as well.
I'm looking at what Benaberry said on the comments section, and he wants us to talk about nature versus nurture. I don't know in what context. I think he was saying in the context of behavior, but I guess we can generally discuss that.
Yeah, I mean, that is something that I just won't get into because I am a complete ignoramus on that one. I think Dave might be the person to go to for that one.
I can give it a shot.
Go for it then.
I guess it's interesting having biologists and me as a psychologist here because we perhaps won't see eye to eye. At least not, you know, I guess on a superficial level, I would probably say the obvious answer is it's an interaction. We're not completely, you know, biologically programmed to do things. We have predispositions. So, for example, if both your parents smoke, that doesn't guarantee you're going to smoke. It just means you have a predisposition. The problem with psychology, in particular, is it's almost impossible to, you know, take away one's gene or one's environment. You know, we, rightly or wrongly, you know, we have ethics in psychology, as in all science as well. So we can't just put a child from birth in an isolation chamber and see what happens because, you know, people don't really like that. So when you say, you know, when both our parents smoke, is that because of there is a gene for, you know, smoking or a predisposition to smoking, or is it just the fact that you have cigarettes available in your house, or you have, you know, social learning theory, so you see your parents smoking and think, oh, they look cool, I'll do that. So when it comes to any sort of behavior, there's got to be at least some sort of interaction. Although, you know, you could say, why do we nurture? Because it's natural. So we could argue that even, you know, nurturing behavior is itself natural, that the reason why we raise children to be certain ways, to become adults in certain ways, is because it's natural, it's because it's what we do. So I guess without sounding like I'm sitting on the fence, which is pretty much what I'm doing, it is an interaction, but how far that interaction is or what the spread of the interaction is something that would probably be debated for as long as there's ethics in psychology and in science, I think.
I mean, I think just in general it depends on the trait. Some traits are highly genetically stereotyped, like eye color, for instance. I mean, unless you have some sort of horrible developmental defect, if you have properly developed eyes, the eye color is, you know, it's pretty much just stably determined by what your, you know, the genes that you got from your parents. But then you have something like height, where it's obviously an interaction because, we know the effect that diet has had in the history of humanity on how tall people are. So I think, and then there are certain traits that respond more to the environment than others, which is where the really interesting stuff happens. And we're just starting to understand how these things differ across populations and across different traits, and it's really interesting. I don't know that I can. My answer always is it's all of the above, because it just depends on the trait, and we're not at it. Genetics isn't developed enough yet, and it's getting there to where we can actually go about answering this question in any sort of significant way.
Mm-hmm.
Well, and then we have epigenetics.
Yeah.
Yeah, which is another huge, that's a huge thing that we don't really, I made a video on this for Tommy, and of course he didn't watch it, but it's not. I mean, we're right now just discovering what these things are. So, and in the sense that how heritable epigenetics is, previously wasn't thought to be terribly heritable, but we had the insight that it would be heritable based upon several disorders that happen when epigenetic regulation goes wrong. But who knows? It's interesting, and I'm excited for the new research, but that's all I can be.
Right. I'm seeing if we've got any other questions. Or have we answered all the questions in the world?
We have answered all the questions about science, Fiona.
I think
You have done your good deed for the day.
Yeah. Sorry, Jade.
Oh, that's okay. I would just like to, because Sam brought up eye color, and this just reminded me of, I worked with a woman once who had bright gold eyes. Now, we're not talking about what normally you think of as gold eyes, which is sort of a pale brown. I have never seen eyes her color before in my life, but never since. She had a sister who had the same.
I can barely hear you.
I can't. Yeah, I can't hear us. You gotta speak up.
Fiona,
Okay. Whoa. Can you hear me now?
Yes,
Yeah.
that's much
Okay,
better.
I just have to move this damn thing. I've injured my headphones, and I'm getting new ones, so that's. Anyway,
I've turned you up as well.
Okay, I worked with a woman who had bright gold eyes. And not the kind of gold you think of, the normal light, it's sort of a light brown. Her eyes were freaking gold, dark gold. And she had a sister who had the same color eyes. And I've never seen eyes like that before or since. And she told me it was due to, the doctor told her it was due to a fused gene. Now, I have no clue if that was true or not. This was years ago. But I was wondering if you've ever heard of anything like that, because it was really unusual.
I have a friend who has heterochromia, which means that he has, he's one of my best friends, his eyes are two different colors.
Yeah, I've seen that before, but I've never seen anything like this deep gold, and I don't know much about the heredity.
Yeah, actually, one
I
of
don't know
my
much
best
about
friends.
eye genetics, Can't even speak.
No clue. That's
Yeah, I'm just curious.
I know the mechanisms of genetics better than specific genes.
Yeah.
One of my best friends had heterochromia, or whatever you just said, as well. It was very odd. Yeah,
David Bowie has it.
Yeah. Oh well, my friend John Wozniak, who was the lead singer of Marcy Playground, has two different eye colors. Yeah.
Yeah, I had a dog who had one eye that was bright blue, a very light bright blue, and one that was really dark brown. It was really,
Yeah.
People
Same
would
here.
stop their cars to look. Yeah.
Yeah, my dog Aurora has one blue eye and one brown eye. She's so pretty.
One thing I did want to mention while we're talking about genetics, how people who don't understand often will ask, well, where is the gene for that? As if there is a gene for everything, and it doesn't work that way. One of the simplest examples being a poultry raiser I know of is egg color in chickens. There is no gene for egg color in chickens. To begin with, egg color we see is actually caused by two different color layers. So what we're seeing is the interaction of these two different color layers, which is why we get eggs that are brown, eggs that are green, eggs that are blue, eggs that are gold, even some pinkish ones, as well as some really beautiful dark red ones and some dark brown ones, as well as white ones. So when people, but you hear this a lot from people who don't understand. They'll go, well, where's the gene for that? I want to know where the gene for that is. It's not a simple gene. Sometimes it's not a simple trait.
Yeah, it's networks. I mean, this is what systems biology is. I mean, I'm currently taking, because I'm a first year and I'm not only doing research, I'm taking a course on systems biology. And there's the idea that, certain traits are, and certain genes and proteins are organized into these like modular networks. And it's a really thrilling future direction. But very few traits are incredibly genetically stereotyped to the extent where it's one allele, one trait. Usually it's a combination of things, and that's why, genetics-based medicine has had some success, but it's taken a while.
We have a related comment from Great Rottweiler in the comments. What is the most uncommon eye color in humans?
Gold.
Regular eye color, beyond the dark gold that I've mentioned, which is just an oddity.
Yeah.
Could it be red for albinism, or is that too common?
No, that's an unusual one. I think he means like within the range of normal coloration.
Green, right?
Either green or gray, I would think. I'm not sure.
Yeah, I've met more people with gray eyes than green eyes.
But yeah, really green eyes are not that usual.
So we've got a comment. It's from, who's it from? Is it George Saint? And he said he made a statement below about 30 minutes ago that he'd like an opinion on. Now I'm scrolling down and I found a statement from him, but it's 5 minutes ago, but it was edited. So that might be the statement he's talking about. And so I'll go with that. And it was, since currently you cannot say anything about the nature of God, all-knowing and all-powerful, you can also have an exclude that in the future science will never be able to examine God or gods, provided they even exist. The word supernatural is nothing else than a word for saying we don't know what it is. Meaning, the entity of a god or gods is nothing else than the knowing this entity or entities exist. Science has just potentially not discovered or detected it yet. To claim we will never know the supernatural exists, or we will be able to detect it, is to position yourself in the mind of a god or gods and its intent for the universe and us, and is a position from arrogance by the religious.
I can't say it any better than that. I mean, it just, for me, the thing that concerns me about intelligent design is less and less that it's got this, religious implication, but more that, you need to actually be able to test things to do science. So what you're doing is you're trying to inject religion into a scientific debate when, if there's legitimate experiments to be done. This is what I say, if I want to test the function of a gene, I can talk about what experiments I would do. If you want to test if that gene's intelligently designed, please I like money. I'd like to get the NIH to pay me to do research. So if you've got something profound to say, please.
And there's the thing. They've proposed absolutely no test, no experiment whatsoever. All they do is take information, twist it around, and say, well, that proves intelligent design. But they've actually done no work whatsoever themselves.
Oh, well, actually, there was something done. I think Behe ran a computer simulation.
Ah, yes.
To do with probabilities. And he worked out that in the population size that he was using, that it was highly improbable. But there was a problem because when the lawyer in Dover then translated it into the number of bacteria just in a ton of soil, and it meant that it could happen once within 20 years.
Yeah, that's right. I remember that.
And I sat and worked out, trying to work out the sort of the amount of soil on planet Earth, and it worked out that, given Behe's own figures, that there were enough bacteria that it would be happening every, I think it was it 2 hours?
Yeah, something like that. I remember it. I mentioned on the Nova episode, actually.
You're talking about malarial resistance to chloroquine? Is that what we're discussing?
No. This is it was a hypothetical about getting 2 specific changes in the one individual, and he was working out the probability of that happening, given all the various parameters can be changed.
Okay.
But the problem was that he was working it out on a population of something like 200 hypothetical bacterial cells, except the planet's got more than 200 bacterial cells. And even in a ton of soil, there are enough bacteria that even using Behe's probability, it would happen once in every 20 years.
Yeah, but once again, it doesn't actually show that there is any supernatural involvement in it.
Exactly.
Even in his own experiment, he doesn't actually provide a method for testing a supernatural interference.
Yeah, well, you see, I'm trying to keep the supernatural out of this when it comes to intelligent design, because of the screams and squeals that send over. They have actually made an effort to distance the science of intelligent design from the religious aspect. But the other example I would bring up is a paper by Axe and is it Gauger?
Doug Axe.
Yeah, Doug Axe and Gauger. And what that highlighted was a flaw in experimental design. They took 2 proteins, biotin, biosynthesis pathway, I think. Two proteins that were ancestrally related. And if you imagine that it would be a sort of Y shape, branching off. And what they tried to do was, we'll call them protein A and protein B. What they tried to do was force protein A back down the branch and up the other branch to make it turn into protein B. Okay? Now, there's a couple of problems with that. For the if you just think of it simplistically, for a divergence on a Y shape like that, you're talking about a single step. But to try and not just retrace it but go up the other branch, you would need 2 steps. If you're trying to force it back down the path. And the other problem is, if you're just trying to force it across that gap at the top, this is where the cousins problem comes in. Because if you look at 2 cousins, they share grandparents. They have the same grandparents. And the way the experiment had been designed meant that because protein A couldn't become protein B, therefore they couldn't have been descended from a common ancestor. What they were basically saying was that these 2 cousins couldn't be related via the grandparents because you couldn't turn cousin A into cousin B. Now, I think you all see the flaw in that. Silence.
Yeah, I mean, I had nothing to comment.
Yeah, I mean, basically, the way they were thinking was that because they can't turn you into your cousin, that means you do not share grandparents.
Which is absurd.
Absolutely. I think this is why it was met with a silence, because it is such an absurd idea.
Yeah.
But that is the way the experiment had been designed. It was a flaw in the experiment. They asked a question, and then they designed an experiment which actually asked a different question, but they didn't realise that. And then they took the results of that experiment and applied the answer they got to their original question. And that's the flaw. They didn't realise that the experiment had been designed so that it didn't answer the question they were asking. It actually answered a different question. It was published in Biocomplexity, which is the ID's in-house journal, with a flaw as big as that you can drive a truck through. It wouldn't have got published anywhere else. But that was at least an attempt. But it has been admitted by Gotcha that one of the big weaknesses in that experiment was that the two proteins weren't closely enough related. They were actually quite distant. So they were attempting to witness something happen in a laboratory that, given the bifurcations, you would actually double the number of steps that it took to get there in the first place. So if it happened over the period of hundreds of thousands of years, and they think they can sit in the lab and watch it. So that was another problem with the experiment. One other of Axe's papers, actually looks at the evolution of a type of, it's like a Chinese character. It's basically a computer simulation, again. The problem is this, that if we don't understand the mechanism by which they're claiming design happens, then how can they calculate anything? How can they simulate anything?
I mean, it's one of these things where any type of pseudoscience. I mean, this is the problem that I have with, the online journal system, is that it's really cheap to have shitty journals now. Yeah. And what that leads to, an example that I gave is someone who will not be named decided to send me this Rupert Sheldrake article where he was like, look at this proves like psychicness. And it was this bird who apparently they looked at what words it would say when its owner was looking at pictures in a different room. Now, what's the logical control for that? That's pretty simple. Any freshman who's taken, done a semester of research in a lab would know. Well, you need to also look at what words the bird will say when there isn't any stimulation, just as a control. Mm-hmm. And that's basic experimental science. He didn't do that, and he then complains that the mainstream won't accept his findings when he puts together this, and I hate to swear, but absolute dog shit paper. I don't like to call papers, like, if I don't like the paper, I would never try to debase it like that. But with him, I just have to, because it's very weird. If you set up a journal, people instantly think that's respectable, but peer review is, most people don't know what it is.
Mm-hmm. Yeah. They think it's a bunch of people patting each other on the back.
Yeah. Oh, go ahead.
Yeah, I was just going to say, somebody linked me to a journal article the other day saying, see, look at this. And I looked at it, and it was an open access journal, and it said public peer review. So I'm guessing that means the public who reads it peer reviews it?
Yeah.
And so what worth is that?
Comment threads? What?
Yeah.
Yeah. Well, there was a. I commented. I just remembered because somebody plussed me today, but I commented about a month ago or a few weeks ago on a quote-unquote debate between medicine and homeopathy held at one of the homeopathic schools. And the debate was, does homeopathy work? And they took a poll. They kept taking polls, as if medicine is based on some sort of democratic understanding of the advances in medicine and what medicine is, and that's really, and I commented that this is exactly what's wrong, is that people think that there's some sort of democratic, consensus as to what science is, or what constitutes legitimacy in science, as if the general public can have a say, and frankly they can't. They don't know enough. Once again, you don't have people debating astrophysics when we send up rockets. You don't have the general public debating other things in science, how to build cell phones, because it's idiocy to think that that's how science works. But when it comes to anything that involves woo, that they sort of goes against their worldview, they think they're entitled to question everything themselves, when they don't even have the beginnings of the foundations to even understand this stuff. So that it's really the root of the problem, is the perception that people have some sort of democratic voice in these things. They don't know enough. And when they don't know enough, they should shut up and listen, and they should learn. If they're that interested, they should go to school. That's what you have to do.
The ironic thing about homeopathy is that would be an incredible achievement or incredible breakthrough in medicine. Instead of having to mass-produce pills and stuff like that, just make one pill and then just keep diluting it forever and ever and ever.
Yeah, not only that, you would overturn physics, you would overturn chemistry, you would overturn biology. I mean, everything that we know about the foundations of science would be overturned on their head overnight if homeopathy was actually true, did actually work. And that's not really up to a democratic consensus. It's not a social policy. It's not something that most people can even comprehend, frankly. So no, I think that's a real problem.
I think I grew up, by the way, in a creationist household. I was actually a creationist up through a few years ago. And what I'll say on the whole issue of trusting science, I think one of the things that's really missing is that people who don't take university level schooling in the sciences, at least, don't understand the process. They don't get any of it. It's I think Fiona just mentioned something about that. Is they don't even really get what peer review is.
Mm-hmm.
And I think that because I certainly what I was taught growing up is that this was all just sort of a something that most of the scientists really never even thought about, how silly these evolutionary ideas were. They were that the people that they learned from kind of beat it into them in school, and then they just regurgitated it thereafter.
Yeah. Can I ask you a question, please?
Yeah.
So you were a young Earth creationist.
Yeah.
What was your reaction when you realised that, well, basically you've been lied to?
Well, I know okay, I guess. Do you mean by my like the people that raised me and taught me this stuff?
The people that I say lied to, maybe that's a bit strong.
Well, because I'll tell you, to this day, they still strongly believe that.
Yeah.
And so they certainly didn't lie to me. In fact, I'll tell you that right now, I have been racking my brains for ways that I might be able to bring my understanding back to them. Because we're talking about my parents, my church, people that are that I grew up with that are very important to me, and I would very much. I just came to a different understanding of the evidence. I would very much like them to have the same opportunity.
Yeah, because I've found that in quite a few people that as the sort of the penny began to drop for them, they became very angry. organisations such as AIG or CMI.
I really have an issue with Ken Ham. I mean, his book was the first one that I read that sort of made me a zealous young Earth creationist.
Mm-hmm.
Yeah, I agree. And folk like well, I mean, Ken Ham's a good example. Hovind, Dr. Sarfati is another example.
Yeah, I know him. I'm familiar with him.
I have a real or Dembski I mean, those people. Yeah, they upset me because I think they know better and are lying. But again, what I can't do, I can't be upset at people who basically just don't know any better and have never. I mean, there's not really any reason for them to go out and try to know any better because they're very comfortable with the knowledge that they get. I'm Church of Christ. We have the Apologetics Press. If you've ever heard of this organization, it's an apologetics organization. It does a lot of creationist writing, and they're very intelligent people. And and most members of my family give them money pretty regularly and subscribe to all their newsletters, and my family actually among them gets 3 or 4 copies of every new book they put out. They put out a lot of books for kids, by the way, a lot of coloring books and illustrated books talking about God making the dinosaurs and man living with the dinosaurs and all that good stuff. And so, I mean, they feel that, like I said, they're just very comfortable in what they know and what they understand, and really, and they have no reason to want to go outside that, and that makes it a very hard conversation to have.
I can see that.
I understand kind of what. Sorry.
I suppose. I mean, I would take back me saying about how you felt about being lied to, because when I think about it, none of the people that you had contact with were knowingly telling you falsehood, which is what is defined as a lie. So, I mean, I'll certainly take that back. What I'm concerned about are those like AIG who have been corrected on their misinformation, but can still continue to spout it.
Well, and can I say something else? My family, which is creationist, has always been extraordinarily pro-science. Okay, my dad had me reading science fiction books from the time I was 10. We were very pro-medicine. We always go to the doctor and follow the allopathic set of treatment. We always make sure our doctors are up to date on the latest in the medical journals. We're not, it's all evidence-based treatment. My grandfather helped design the SR-71 fighter jet.
The Blackbird.
Yeah, the Blackbird. Yeah. And
wonderful plane, by the way.
Oh, thanks. Yeah, so he was involved in that process, and I mean, these are very intelligent people. They are very pro technology. They're very they're not Luddites, or neither are they ignoramuses about a lot of things. Every one of them has college degrees. They're very well educated within their fields of expertise. They're very smart. But none of them have formal science. None of them have formal training in biology.
I just wanted to mention something. I assume that he was an engineer.
Yeah.
So have you noticed that for some reason a lot of engineers turn out to be creationists compared to other
and mathematicians.
Actually, Apologetics Press, which I was saying is sort of the AIG for our particular flavor of Christianity. They're all of their top guys are engineers.
For some reason, I think it must be because of the way they see structure, and numbers. But it just seems to be that there are quite a number of engineers compared to any other scientific type.
If I may, sorry.
Yeah, go ahead.
If you had one more point to raise, go ahead. I was going to address Fiona's question.
Oh yeah, no, I was just gonna on the engineering issue. What my thought is this: engineers, but are spending. I mean, the entire career of an engineer is based on design, and perfecting design, thinking about design, identifying elements of design, reverse engineering other engineers' design so they can fix it or improve upon it. And so it would make sense to me that a brain that is so tailored to, so trigger happy on design, would tend to see design in places where there isn't any.
Yeah.
Well, hold on. I just want to interject here because technically, even if we talk in terms of evolution, we could sort of see systems designed through evolution. That's the difference between teleology and teleonomy.
Well, yeah, and evolution is used as a tool in engineering, but not, by everyone. Especially, you think of some of these like older engineers, some of the creationist apologists that were mentioned. Those tools were not used in their field back then. They might not have the same understanding of it. So
right, it's a relatively recent phenomenon in engineering. Yeah, it's true. Yeah.
Right. Well, I was reading a bunch of series of commentaries for this course on systems biology that I'm currently taking, and one of the interesting things was one of the guys was like, well, let's look at this from an engineering perspective. If it's we should expect that that it will be designed X way, just a priori if it evolved, versus, he was saying that if it was just sort of this top-down design, you'd have this one streamlined pattern of how things work rather than a collection of these little modules of how things work. And he was saying, well, when you look about it as a principle of design, it looks more like open source software, something that naturally just evolves rather than something that's top-down designed. That is really interesting.
I'd like to address Fiona's earlier question, if I could. Oh, yeah. What she asked Adam. I definitely felt like I was lied to when I fully came to understand evolution, which was really through the YouTube atheist community, because I was homeschooled and creationism was taught there. And then I went to a Lutheran high school, and evolution was just not taught. It was just ignored. And I was never a zealous creationist or an apologist. I didn't have a problem with the idea that God could create through evolutionary processes. I just believed in, I guess I was more of an intelligent design advocate than creationist, but I only followed that because I thought that was what the evidence held. What the evidence supported, because that's what I had been taught. And when I found out that that was completely wrong, I was definitely angry and definitely felt that I was lied to, and that's what started my whole deconversion, I guess.
Yeah, that I think that's something that I was going to get into, because I've noticed that there have been many young Earth creationists who, when they do see the evidence of either an old Earth, or they see the evidence which supports common descent via evolution, they throw their entire faith out, because it does. One of them once said to me, if they've lied to me about that, what else have they lied to me about? And they just threw their whole faith out. And that's the danger I see in young Earth creationism, in that it can push people away from their beliefs.
Well, it's this thing where, these people start to... So this is... The people that concern me are the ardent creationists, right? I know people who were brought up in creationist households, or who really are still sort of skeptical about the idea, but, for the most part, they're not going to, go and advocate for ridiculous things. A lot of the time it's just that they haven't heard the ideas, or they're ignorant, and I don't think ignorance is a crime. But the other thing that I will say is, when you have people the thing that concerns me is when you have people like Tommy, like True Empiricism. These are people who want to pretend like they are legitimately saying scientifically justifiable things, when they're
Yeah.
not. And what that does is that misleads people. That's where lying and dishonesty comes in. So my issue is when people are peddling this as if they have their own legitimacy, because of the fact that you have places like Answers in Genesis and the Discovery Institute that create their own journals to pretend like they're legitimate. That's what concerns me, because you're getting people who are saying, if people go, oh, it's my personal belief, then I'll be like, oh, good for you. Like, I'm not going to try to, as long as you're not affecting me getting my funding, I really could care less. But these people are instead trying to make it so that they are actually, scientifically legitimating what is a personal faith issue, and that's what concerns me.
Yeah.
And I think that there are the people where evolution was never a big part of their faith are people who just, generally accept that it's a personal, that, their faith is a personal idea rather than some public identity they need to make a big show of for everyone else.
Now, one of the things with Tommy Hall especially, I find it so funny that, and even true empiricism is sort of the same way, when you actually press them to give you real legitimate sources, like actual peer-reviewed papers, they just go through every single excuse not to give it to you. I had that thing with, I got into a huge comment argument with Tommy Hall a few weeks ago. I kept asking him over and over again, and he would find he used every single excuse in the book not to give it to me. And then after enough times when I pressed it on him again, he said, I don't have to anyway because scientists are conspiring against you in the first place. So
well, the other thing is that, and a lot of these people will do, is they'll look and they'll see an abstract of a paper, and that abstract could somehow, as that abstract could somehow be taken as the totality of the paper and not actually read the results.
Yeah. There's actually an example.
That's exactly same thing.
There's a
with
beautiful example online at the moment, and I will attempt to find it. Or you may, I don't. Maybe you've all seen it, and it's a video that was made, and it's about 2 headlines on the front of New Scientist.
Richard Raspberries.
Yes, have you seen that?
Yeah.
Right, and based on the headline on the front of it, on 2 issues, he's declaring that New Scientist is publishing rubbish. The problem is he's actually misread the headline.
Yeah, well, that just happened with you and Nephilim Free a few hours ago. I mean, that was classic. He just reads the headlines and he deduces from the headline what the paper is about, and it was absolutely as clear as day when you challenged him on the contents of it, and he was absolutely wrong on the contents itself.
Yeah.
He did the same.
One of the classics recently is this exaggeration, the exaggerated headlines. Everywhere, National Geographic, Scientific American, New Scientist, whatever, about the ocean of water discovered deep in the earth.
Yeah.
I can't tell you how many times I've tried to explain to people there's no ocean of water down there. It's hydrates in rock.
Yes.
Rock called, what is it, ringwoodite? I always get that confused. And I've had people come up to me and say, but don't you see the flood could have been real because the oceans in the deep rose up because there's an ocean of water down there.
Yeah.
Ocean of water. And if you and yes, it does speak about how, mind you, this is a new finding and it's only based on a small sample. Let's keep that in mind. But what they're suggesting is, yes, over time, some small amount of water from those rocks, due to pressure, works its way up to the surface. This is hardly the fountains of the deep ocean opening up. But it's been, I don't know how long, and I'm still trying to explain to people the ocean.
Yeah. And the other thing that I noticed earlier on was that I would be asked a question, I would answer the question, but then he would continue on as if the answer had never been given.
Yes. Yeah, he wouldn't listen to your answer at all. I mean, it was. I knew he wouldn't. I'm glad I invited you there because I really wanted somebody. No, but I really wanted somebody to put him in his place. Somebody who has the legitimacy. And I mean, once again, he has no legitimacy. He has no real research. And somebody, I couldn't comment on it, and I think most other people really couldn't comment on it. But
I tried.
Yeah, Nick, you did a fantastic job, I have to say, and I really liked it when you got angry with him too.
But can I just say something? The funniest thing is that when Fiona was debating with him, I kept in the comment section, I kept posting all these links to Science magazine of how to observe the instances of speciation, and he didn't comment on it once.
Yeah. But you see, the thing is, he's homing in on this new anatomical features. Yeah. Now that means, and having pressed him on this previously, basically he wants an instance of a new anatomical feature that's never existed before. But how can you give him an example of something happening in the past if you cannot use an anatomical feature that existed in the past? Do you see the difficulty? Right. The only new anatomical feature, it's got to be something that's never been there. So, I mean, what are you going to call it? A gumbalumba?
Yeah.
Well, you'll notice in that, Fiona, he did mention those bones in the dinosaur skull, which I'm going to look up.
Yeah,
and so apparently those bones are new anatomical features, but if you remember previously, we had a little go round with him about a brand new blood vessel from the heart. But that's
exactly. Yeah, but blood vessels existed.
Well, so
prior.
My question
count as a brand new anatomical feature. This is it.
But then skull plates also existed previously. So
example of something happening in the past. If you cannot use an anatomical feature that existed in the past, do you see the difficulty?
Okay, I think you have the stream running, dude. Muted.
What's going on there? It's got to be something that's never been there. So I mean,
think he has the stream on.
Jeff,
I tried to
have
mute him.
you're playing the video in the background. I know we can hear it.
He's also lagging because my mute didn't go through.
Yeah. Yeah, I'm not quite sure. I mean, but that was me trying to explain that he's demanding an anatomical feature that didn't exist before, and he wants a mutation for it. A mutation.
But he wouldn't listen to your answer at all. And then when he mischaracterized RNA completely, and you corrected him on it, and he wouldn't accept the correction. He denied that. Anyway, I
what do you say about RNA? I'm interested because right now I'm using RNA sequencing.
I'll let Fiona answer that.
Well, he first of all he tried to say that RNA could only be about 10 amino acids long.
But RNA is not made of amino acids.
Exactly. I pointed that out, and he still repeated it.
Yeah.
He after I corrected that, he then went with it again.
RNA can be very, very long. Long non-coding RNAs. Which
No, but we're talking about. We're not talking about that. We're actually talking about RNA molecules that can arise just purely through chemistry. We're talking about abiogenesis.
Oh, we're talking about that?
Yeah.
Okay.
Yeah. So that was that one. And he then tried to say you can't have RNA without DNA. Well, we've got RNA viruses. Ebola is one of them.
Yeah.
Yeah, and I mean also it's easier to synthesize RNA than it is to synthesize DNA because it's hard to do that that deoxygenation of the base.
Yeah, and he then switched it to well, how could the ribose come about? And when I tried to actually answer him on that, it was the final straw for me, because I've been getting, as he would get his 2 minutes to speak, and then I would get my 2 minutes, and I would start speaking, and he would start laughing.
Yeah, he was being very rude.
Or there was a load of noises in the background coming from him, and I had to keep pausing. And when I tried to actually give him some information about how ribose can form, and the same thing happened, I just stopped speaking, and I went no further with the ribose, because I thought to myself, there is no point. I put a link in the side chat so that anybody who was interested could have a look at this formation of ribose.
Well, it's one of those
enzymes.
things where, and again, this is, why I get frustrated with Tommy, is he'll say something that's just so completely counterfactual about a field that I actually work in, and I'm just like, that's not the case. I was like, I wrote my thesis on the topic of what determines what a gene is.
Yes. And the other thing was that I mentioned about self-replicating RNA molecules in a protein-free system. And then he then said, but it needs enzymes.
Yeah.
Enzymes are proteins.
Yeah.
If it's protein-free, there are no proteins. There are no enzymes. And it's that level of ignorance that you're having to deal with. I mean, the easiest way of saying it is, it was a protein-free system. There could be no enzymes, and yet he doesn't understand that given the enzymes are proteins, that statement then means there can't be enzymes.
Yeah, I'm wondering if he is in the category of Ken Ham. I think that he knows. He knows far too much. He knows. I mean, I know everything he knows is twisted, and I know that he doesn't understand fundamentally. But I'm thinking it's a deliberate misunderstanding, and he doesn't need to know.
No, I disagree. I think he's a
sorry.
Jade, we can't hear you again. You're
sorry,
being really
every
soft.
time I lean forward, I do that. Sorry about that. I'll have this fixed shortly. Well, I disagree. I think he's a true believer.
Oh, I agree. He's a true believer. I think Ken Ham is as well. But what I'm saying is, I think there's a serious cognitive dissonance going on there. The same with Ken Ham, because they know that the questions, the quote-unquote questions they're asking, have been answered time and time again, and they refuse to recognize even the fact that there is an answer waiting for them, even to debate that. They just refuse to recognize it has been addressed at all.
So I think it's both, personally. I think that Nephilim-free, anyone who's talked to him about a subject that's not evolution, he's similarly incompetent. Like he's very similarly ignorant about political history.
He's a geocentrist. I mean, say no more.
Yeah, and so, but what I will say to that end is that he's also dishonest, though, because he knows that people have pointed out his mistakes, but he just refuses to say that they're mistakes because he's so arrogant. So it's one of those weird things where I can't say, is he just an idiot or is he a dishonest huckster, because he's both.
Yeah, I agree.
We have a comment from Tommy regarding this. No, Fiona, regarding mutations not adding new anatomy, mutations or even a mutation do all kinds of things that can be seen and tested in real time. Duplications of existing features, removal of existing features, resistances, changes in fur colour and eye colour, changes in reproductive habits, all kinds of things. But adding new anatomical features is not one of them. Thus, common descent is impossible without this ability.
What does he mean by new anatomical features?
Hey, Tommy, I'm pretty sure I've heard you say before that mutations don't convey any beneficial, traits.
contradict much?
And I would like to point out that a mutation that adds an extra blood vessel from the heart, a major blood vessel, not a capillary, is a positive mutation, and in one case, it saves somebody's life. There you have a brand new feature caused by a mutation in human beings, and a bunch of us know someone who has that mutation. Same as serious mind.
Yeah. You see, they cannot give me the definition of new anatomical feature.
Well, they know they're being vague about it. That's sort of the tactic. If you're going to be vague with your terms, you try to make other people do your homework for you, and then of course, if they try to do your homework for you, you can simply go back to the same vague definition and say, "Oh, you're not actually answering it." It's the same thing, and it takes in different forms. I mean, I know about a year ago we were all like, "What's the deal with these creationists and how they use the word kinds?" Now they like to switch it up and they move on to different terms. That's nothing that's nothing I didn't expect, in all honesty.
Yeah, it was all about kinds, especially with what's his name, Banana Man. Yeah, and then King Crocodile challenged him on it for quite a while on video, and then they seemed to move on from there, I think.
Oh, I know. He just completely crashed and burned there. I mean, he didn't even answer. That was the funny thing. And then he just simply said, "Well, it's because God made it that way." That was his answer. And I took a lot of enjoyment out of that.
And then King Crocodile did that whole video explaining why, his entire view was completely ridiculous.
You don't use terminology in science. That's just something you do not do. You have to be as least ambiguous as possible if you want to maximize the explanatory power of the theories and hypotheses that you're trying to test.
Right. Exactly. Exactly.
Well, again, I'm going to just say I don't have any interests in these types of posturings if they're not going to come forth with something I can actually test.
Well, I know. Yeah. But that's sort of the whole thing is this. When we talk about why vague terminology is bad, I mean, I think for most of the people in this hangout, I mean, this is like first grade to us. We know this is not a difficult thing to understand.
I mean, they know. I mean, these people, a lot of them know what they're doing. Like Tommy Hall, like I just in the comment section, all I'm doing is say, "Did you read it?" And
excuse me, may I say something? Jade, do you have a paper for this blood vessel?
No, I don't. I'd have to talk to Serious Mind about it.
Yeah.
I will contact him and talk to him about it. I know he's not the only one that has it, but I'll talk to him about it.
I'll tell you this because Tommy Hall has commented, "I want the link from the snail lady. Paper, please."
Okay, well, yeah, and I do that to him all the time.
The thing is, you've actually got better than the paper. You know the guy.
I know the guy.
You know the guy that's got this.
Yep.
Let me just say something to Tommy. Listening.
He did a. Can I wait a minute? He did a video on this, and I will look for the video, and I will try to get a hold of him. I know he just spent some time in England, so maybe he's back home chilling now. But I'll try to get a hold of him and get the information about it. But yeah, this is but this isn't that unusual. A lot of people have different things. The problem is their definition of something different, some new anatomical feature. I have several mutations that I know of. I just happen to know about. And everyone has mutations. Most of you people just don't know about them. They just don't. I wouldn't have known. I mean, I knew I always saw well in the dark, but I wouldn't have known why until ophthalmologist said, "Whoa, you've got a lot of rods in your eyes," and other ophthalmologists have confirmed that. And it's I'm not exactly sure what causes it, but yeah, I've got a whole bunch of rods in my eyes. I can see in the dark really well.
Yeah, but the problem there, Jade, is that's not a new anatomical feature because
you're right.
Exist. And this is the problem that they don't get. That
I actually do have a new anatomical feature, but they wouldn't buy that one either.
Exactly. The 6 fingers. They wouldn't buy that one because fingers already exist.
Right.
Why can it no lack of an anatomical feature count too?
Well, it's simple. Why these people? It's because they don't understand basic biology. And here's the thing: is you look at the really new novel stuff that is way more risky in terms of just introducing creating these new biological pathways. The really risky stuff on a cellular level was solved by evolution 3 billion years ago.
By the way, may I just point out, Tommy Hall has answered saying, I don't believe her. Evidence, please. Tommy Hall, you are a troll. To say that I don't believe her means you're calling her a liar. You have no evidence to call her a liar. You should say, I don't understand. Please give me the evidence.
And can I
But
say,
no, to
Tommy,
say I don't believe her. Tommy, you're far too ready with that accusation.
and
So
can
I do not
say,
believe any of your questions are ever genuine. I believe the quote that you put onto G+1 Day saying that you only do this because you enjoy getting people angry, that it's a good laugh for you. That's why you do this. You made that comment saying that. Therefore, your comment saying, I don't believe her, means that I do not believe that that is true of you. You're doing this deliberately for a wind-up because you're a troll. So I suggest you take yourself back under your bridge.
Go to bed, Tommy.
Well, the biggest...
I would like to wait just one thing. I would just like to point out to Tommy that there are at least a couple of hundred people, if not a lot more, here on YouTube that are familiar with this situation. Because Serious Mind has done a video about it. He's talked about it. Hangout. He's not doing Hangout so much anymore. You know, it would be interesting to get him into a one of these Hangouts too, because he's a chemical engineer.
Yeah, but the thing is, what they will want, Jade, is they will want us to pinpoint the mutations.
Right.
And the thing is, we can't.
No,
this is the problem, because it's trying to untangle some of these more complex changes in anatomy. It can be very, very difficult. And especially when some of the changes may also include a temporal gene expression aspect.
Well, also, I mean, what I was sort of in the middle of saying was that a lot of the hard problems with the cell, where we're getting these new, these new functional pathways, most of them were solved, billions of years ago. So a lot of what the new pathways are now in species is just variations on already existing themes, because of the fact that gene duplication for sexually reproducing species is such an easy mechanism for changing the DNA without causing anything terribly deleterious a lot of the time.
Yeah, I don't know why I have extra rods in my eyes. Is that a gene duplication or what? Go to have it tested, and maybe they could find out. But as I said, we all have these things. On top of that, it gets more complicated because sometimes people have genes, those genes are not expressed. You don't see that. And a classic case, for those of you who are listening, is they cloned a cat named Rainbow. Rainbow is a calico cat, female calico cat, and they cloned her. Her clone is gray and white. Now, they're identical. They tested them. They have identical genetic structure. But the genes for calico coloring were not expressed in her clone.
Yeah.
So they look alike. Not only do they have different coloring, one is slim, one is stocky, and there's a couple other differences. And they even let Cece, the clone from Carbon Copy, have a litter, perfectly normal cat. So that complicates things when you have genes that are there and you're trying to track them down, but sometimes they don't become expressed. And they deliberately cloned a calico cat because the genetics of calico cats are pretty well known.
Yeah. Did you? I actually heard tonight the little kitten was called CC. And do you know what CC stood for? Copycat.
Oh, it was copycat. Oh, there you go. Oh, okay. I thought it was But yeah, you could look online and you can find all about Rainbow and CC. And they have cloned entire herds of cattle. They're not identical.
Yeah, scientists do have a bit of a quirky sense of humour. Do you know why Dolly the sheep was called Dolly? It's because they'd taken the egg from female sheep A. They'd taken the nucleus out. They got a nucleus from female sheep B.
Right.
And put it, right? The cell that they used from female sheep B was a mammary cell.
Dolly Parton.
That's why they called her Dolly the sheep.
Jed like that.
Yeah, I mean, look at some of these weird things that the Drosophila guys got up to when they named some of their mutations. Sonic Hedgehog.
I know. Yeah. Oh, and that's another thing that a lot of the creationists don't understand why the experiments were done with Drosophila. They seem to think, oh, well, that doesn't do any good. You're growing a leg over here. No, you don't understand. They're doing that not because you think that's an advantage, but because that's how you try to map the freaking genes.
Mm-hmm.
And it's also about, being able to understand the underlying pattern of how these genes are functioning. Yeah. I mean, that's the way that with a lot of traditional genetics, and you still have to do it now, is that you knock out a gene and you see, okay, what changed? And then you can, reconstruct. I mean, this is what frustrates me, because a lot of these experiments, when you read them, are very elegantly designed. It's just a refusal to read the studies, and it's unfortunate.
If they'd ever had any education, if they'd ever gone to college and taken basic biology, you would have done Drosophila experiments yourself. Honest, it's not that hard.
Yeah.
And it's a standard thing to do in lab when you're studying. But again, as you tried to say, Fiona, they don't understand certain basic things like bilateral symmetry, the fact that all vertebrates are quadrupeds, all these things that are similar from going way, way back when. So according to their definition, or at least like Tommy Hall's or Nephilim Freeze, there cannot be such a thing as a brand new anatomical feature. Going back to, I don't know how far back, but at least certainly to the origin of chordates.
Yeah. Galaxy Dreams has just found us. So I'm hoping she's going to post some questions, because she's always got questions about science. Because she's really interested in finding out loads more about it. So I've told her to ask whatever she wants, and we will do our very, very bestest to answer her questions.
And also I want to bring something up that I've said to Jade in the past, and we both pretty much agree on this, is that we need to be clear that when we're in these discussions with creationists, when I'm in the discussion, I don't have the goal of settling some sort of debate, because there is no debate to be settled. Evolution is the only game in town. What I am doing, though, is I'm showing my audience how I would answer this type of creationist claim, because a lot of the time, I realize that, besides what I've gotten through my own hard work, I've been very fortunate to, get the opportunities that I've had. And I think that sometimes being able to share, how would someone with my amount of training, whether you view it as a lot or a little, would answer these claims. I personally do not believe that, you should treat that in all seriousness, and of course this is YouTube, so it's not always all seriousness, that that creationists have any legitimacy, because they just simply do not. They're not publishing work. They're not doing anything interesting. It's just important to make sure that people understand this type of pseudoscience being squashed.
Yeah.
What they're kind of doing is, I have a mountain range pretty much just outside my door, right up the hill, coastal mountains. Lovely things. And it's huge, great big, well, they're actually kind of small mountains, but they're still a mountain range. So what creationists are doing, the way they attack evolution, is as if they go up to the mountain and they grab a rock and they away. You go, see, I've just destroyed the mountain.
Yeah.
And it doesn't make any difference. You could run up there, grab a rock, run back a whole bunch of times. You're not going to destroy the mountain. Not only that, but these mountains are still growing. We can actually measure it. So, and it just like the evolution is still growing. The theory that encompass changes, and that's nothing they don't understand. They go, oh, well, this challenges it. No, it doesn't. It just widens it. It makes it cooler. Makes it more fantastic and wonderful. And if you really, really want to believe in creation, I don't care. As long as you're not trying to influence public policy, and as long as you're not trying to lie to people, basically. You know, if you just say, well, this is what I believe from the Bible, I've got no problem with that. But when you try to make the laws, you try to put it in classrooms, you try to limit scientific investigation, then I have a problem with it.
I mean, that's my attitude. I don't like the idea, you know, I was trying to explain to someone, like we shouldn't, you know, if Michelle Bachmann or someone like that had gotten, the nomination or gotten elected, God forbid, you know, I'd have a difficult time not moving, you know, after I get my PhD, not moving overseas because, you know, how in the hell am I supposed to get funding for the interesting research questions when you have someone who's willingly, you know, ignorant and deceptive about what they believe the science to be?
And that's where the problem is. Especially with the politicians and certain people like Ken Ham and these people, what I call the professional creationists, they're all a bunch of liars. And if anybody wants to challenge me on that, I'd be perfectly happy to go to Answers in Genesis, Creation Ministries International, or wherever, and show you exactly how they are deliberately lying to you. And one of the things that's really appalling about this, these people are calling themselves Christians, and yet they're lying to other Christians. There's something really wrong with that. And again, if you really, there actually are a few creationist sites that are honest, and they'll say, we can't prove this, but this is what we believe and why. But most of them are a bunch of liars. They are lying to other Christians, which doesn't seem very Christian to me.
Yeah. That's what bothers me. Because when you get this thing, if you don't believe in young earth creationism, you are not a Christian. That really bothers me, because there's nothing in the foundations of Christianity that says you have to accept young earth creationism. And I think that there are many who find themselves unable to accept young earth creationism, who will then think, well, I can't be Christian. And there are others who go down the route of, well, they've lied to me about that, what else have they lied to me about? You know, I think young earth creationism has done a lot of damage to the faith. And I mean, it's a reasonably recent phenomenon. You know, we were talking about, it really took off in the 60s.
Yeah, mostly because of, what is it, Philip Johnson? Is that the guy, I think his name was, who was the attorney who started this nonsense? And sadly, he started it not too far from me at Pajaro Dunes. Lovely place. Too bad it has that, you know, in its path. But yeah, he was an attorney, and he thought that he could apply the principles of the law to evolution. The problem is you can't really do that. It doesn't work that way. It's a little bit like trying to apply the principles of mathematics and biology.
Yeah.
Different subjects matter altogether. It doesn't work. You're trying to measure things by the wrong yardstick. But yeah, a lot of people are. The irony of this is that most Christians in the world accept evolution. Most.
Yes.
And this whole creationist business actually started here in the United States with you know, fundamentalism, which comes from a series of lectures, well, a series of articles today that were put in a book called The Fundamentals of Christianity. You can find it online.
Yeah.
That's where the word
listen, guys, we've got a question that I've missed out somehow. It's from George Saint. There's two questions he's asked, and we haven't actually addressed them. I must have missed them. I do apologise, George. First one, are there parts of the original theory as described in Darwin's book on the origin of species that have been corrected by science or proven wrong by scientific experiments later on? So where was he wrong? The second question is, if we ever want to establish permanent residence on Mars, do you think it will require us to permanently change the human genome for the colonists in order for them to adapt to the harsh circumstances there? So basically creating a new human species, perhaps. So who wants to tackle what, and in what order?
Well, I could take the first one if you want.
Yeah, you go for that one, Jade.
Well, what was Darwin wrong about? Not a lot. However, the best way you could say he was wrong is that he was very limited in his understanding. He didn't know the mechanisms of evolution, although ironically Mendel actually sent him a letter or something, but Darwin was too ill at the time. I think he was on his deathbed to pay attention to it. But his understanding was very limited. The basics of natural selection, he had right. If you really read Darwin, you'll see he didn't go into extreme detail. Probably the one way you could say he was really wrong was in his Tree of Life. But when he drew the Tree of Life, it was a tentative one. Anyway, it was an idea. Unfortunately, one of the problems we have now is that you will see people go back to Darwin's Tree of Life and go, you see, the Tree of Life is wrong. Well, yes, it is that way. It isn't a simple tree. We now know, for instance, I actually have a picture of like our human anatomy, our human ancestry, and where we find that our ancestors kept crossing. So it's not just a vertical movement, you know, this turns into this turns into this turns into this. We find they keep crossing back and forth along the way. So it's not a strict Tree of Life, and we know that. But for the most part, there isn't a lot in Darwin that is greatly wrong. Just incomplete, I guess is the way I put it. Anybody else want to add?
Fiona, if you're talking, you're muted.
Sorry, I'm in a wee whirl of here. I'm trying to roll a cigarette. The fact that Darwin didn't know about genes, about DNA, he did a pretty good job considering.
Yeah.
It hasn't changed the idea of common descent.
He was also very humble about it if you read Origin of Species and the way he presented it.
Mm-hmm. I mean, we're looking at mechanisms because while Darwin had said it was random mutation and natural selection, I mean, yes, there are, mutations occur that are not random, but that doesn't negate the theory of evolution, because most of the time mutations that are occurring are actually neutral and just hang about in the population, and it's only when the environment changes that there may be a selection pressure put on it to either be knocked out of the population or to become dominant in the population, because we get so many random mutations. Each individual has about 120 to 150 mutations unique to them that neither their father nor their mother had. It's quite a high number when you think about it.
Yeah.
And that is random. That's completely random.
Well, it's random within parameters.
Yes, exactly. I mean, there are some types of mutations that are more likely to happen where you've got an AT pair. You know, when you get the formation of thymine dimers, because you aren't going to get the formation of a thymine dimer unless there are two thymines there. So that type of mutation is going to be specific to thymine residues, but which thymines? And that's where the randomness is.
Mm-hmm. Yeah.
So when we say random, we have it's a relative term, because while it's got to be a thymine that's going to be performing thymine dimers, you just don't know which ones it is. Does that make sense?
Yeah, which is why I said it's within certain parameters.
Yeah.
Depending on the,
Yeah. I've told Galaxy to come in because we've got space now. Galaxy, if you're there, come on in.
Because random mutations have to obey the rules of chemistry and physics and things like that.
Yeah.
Or they're not going to survive. Probably one of the reasons why, roughly as from what we understand now, given the latest data, about 50% of pregnancies end in spontaneous abortion.
You've gone again.
Okay, I was going to say about 50%. Can you hear me now?
Uh-huh.
Okay, 50%, around 50%, according to the latest data, of pregnancies end in spontaneous abortion.
That's right, and that's prior to them even knowing they're pregnant.
That's right. This is before women even know they're pregnant. So what that's saying is there's probably some of it, of course, has to do with timing. Perhaps the uterine wall isn't ready, but a lot of it has to do with the fact there's something wrong with the fetus.
Mm-hmm.
So the body automatically expels it.
Yeah. And then, of course, you look at the others that are lost within the first trimester because of genetic malformation. So straight away, you're over 50%.
Yeah.
And I think that's what a lot of people don't realise, that human reproduction is actually less than 50% successful.
Yeah.
And that's a frightening statistic. And it's because, some of the major chromosome abnormalities, they're just not compatible with life at all. By the way, something I wanted to bring up, actually. It sort of comes from the hangout from earlier on, when it was mentioned about chimps having more DNA than humans. And that if chimps had gained all of this DNA, then it would have killed the chimps. Now, I don't think anybody's ever suggested that chimps evolved from humans. So why would they need to lose it? On top of that,
that's the right comfort understanding of it, though.
Yeah. And the other problem is this. It depends on how you are assessing the amount of DNA. Because if you're just doing it on a chromosome count alone, you have a big problem, given the chromosome 2 fusion. Because there's the same amount of DNA, but it's just all on one chromosome instead of on 2. And then, of course, you're going to have to look at the 44 chromosome man. The wee chap in China. He has 44 chromosomes, not 46. Because both the egg and the sperm that made him had undergone a Robertsonian translocation. And it's balanced. It's a balanced Robertsonian translocation. Which means he has all the genetic material that he would have. And there's absolutely nothing wrong with him in any way, shape or form. It's just that he's got a chromosome, or 2 chromosomes are stuck together. And there's also a family in Finland, I believe, that has quite a few members of that family who have 44 chromosomes because they've undergone balanced Robertsonian translocations. And I was recently told by somebody that chromosome fusion is impossible. And yet these people exist and they've been studied. And chromosome fusions have happened. We can study them. We can see them in these individuals. So how can that... Sorry?
I was just going to say there may be a lot more.
Exactly. We don't know. It's been found in them. But I mean, how many people have actually been screened for this?
Yeah.
Now, I'm not suggesting that a chromosomal fusion resulted in humans being human. But what it does do is show how they can have a common ancestor with the 48 chromosome apes. Because balanced Robertsonian translocations do occur. We observe them, so nobody can say that they can't happen. Not when you've got the individual in front of you, where it happened.
Yeah, not just that, but there's also been model organisms that have been studied. Their genetic material has sort of been like analyzed across species lines. I mean, like for example, with fruit flies and mice and other organisms like humans, they found several genes similar to what humans have when they measured it on the molecular level with the chemical subunits, like for example clock genes, which have been found in various parts of the DNA between these species and various other ones. But it's interesting what you could find when you branch out with the DNA. Now you'll hear creationists say, well, that could have been produced by a common designer. However, if that was the case, it wouldn't. I mean, we wouldn't be seeing genetic similarities across species which demonstrate common descent over anything else.
Yeah. I'm just going to check and see if we've got any other questions. Galaxy's not come in. She's probably wandered off to do something else. Let me have a look. I've got to keep refreshing this page. See if there's any new ones popped up, because for some reason it's just not doing what it should do. With the new comments being added on. We've got... Yeah, I've got... Let me see. Great Rottweilers posting a question regarding ID. Why do people still give them attention? IDS, I think they means. Even though prior to the Edwards v. Aguillard trial, it was called creation science. I think people should remember this, even if they eventually changed their name to intelligent design prior to the Dover trial. They at some point admitted it was a form of creationism. Yes, they did. And the smoking gun was, would you believe it? It was a transition.
See, design proponentists?
Yep, yes. It was a transitional form. And the first edition of the book of Pandas and People was about creationism. And so the word creationist or creationists or creationism was used quite often. Yeah. And then there was a court ruling, the Edwards v. Aguillard, in 1889, I think it was, which ruled that teaching creationism in science class was unconstitutional because of the freedom of religion. So the people who produced Of Pandas and Peoples hurriedly started editing their book, and they brought out another version where everywhere the word creation or creationist had been used, they put in design proponents. But pre-trial, pre the Dover trial, during the disclosure phase, the plaintiffs asked for and got all the editorial paperwork from the when they were changing it from the first edition to the second edition, and in there was a transitional form of the book. And what they've done is they've used a word processing software to look for and replace the term creation. Okay? And then just let their word processor do it. But they misspelled it. So they were looking for reation, without the C at the beginning. So everywhere that the word processor found reation, it replaced it with what they'd said it should replace it with, design proponents. And so peppered throughout the text were C design proponentsists, which is creationists with the reation replaced with design proponents. And that was a smoking gun, because nothing else in the text of the book had been changed. So they had a paragraph saying that creationism was the abrupt the abrupt appearance of creatures fully formed. That was fish with fins and scales, birds with feathers, beaks and wings. And in the second edition, it said that intelligent design was the idea that creatures appeared fully formed, fish with scales and fins, birds with feathers, beaks and wings. Word for word the same. And so it was that transitional form that really put the nail in the coffin of the claims that intelligent design, allied over, wasn't creationism. It was creationism in a frock. And I think that there are some who accept intelligent design who really are interested in moving it from religion and having it as scientific. I think the problem there is going to be a really, really fundamental one. Because for every experiment that they run trying to show design in a biological system, what are they going to use as a negative control? I'll just let that one sink in.
Yeah, I've thought about that myself, because I know that there are people who legitimately want to separate the concept of intelligent design from creationism. But how they're going to test it, that's the part that, I mean, good on you, go try and see what you can do, but I can't see how they're going to test that.
Yeah, that is the big problem. I mean, as I said earlier, Axe and Gouger at least had a stab at it. Not a very successful one, mind, but at least they had a stab at it. Behe came up with an experiment on the stand that he said would show design, and he went through all the details of how this experiment would be done. And then the counsel for the plaintiff says, have you done it? And he said, no, it wasn't up to him to do it. It was up to the other scientists who don't accept intelligent design to do the experiment, to disprove it.
So a shift of the burden of proof, in other words.
Exactly.
Yeah.
Behe is the one who's pushing this. It's up to him to collect the evidence for his hypothesis. It's not up to others to disprove. We don't accept something as true until it is disproven. Because otherwise, I could be telling you that there are fairies riding on unicorns at the bottom of my garden, and you would need to accept it until it was disproven.
Or that humans could live 1,000 years, now prove that wrong.
Exactly. That's the difficulty. You can't just accept everything until it's disproven. Because on you go.
Well, I was just going to say, Behe's the guy on the stand who wouldn't accept the evolution of the immune system.
Sorry?
And
can't hear you.
Behe wouldn't accept. Okay, I got to hold this up so it works right. Okay, there you go. Can you hear me now? Okay. Behe's the guy who on the stand refused to accept the evolution of the immune system.
Oh yes.
Oh, you remember that one? Okay. So so the plaintiffs, the guy came up and said, "Have you read this article?" No. Have you read this article? No. Have you read this book? No. He ended up with this huge pile of material in front of Behe so that he couldn't even barely could see over it.
Uh-huh.
And he said, so you haven't read any of these? No, and they're all on the evolution of the immune system.
Mm-hmm.
And he had to ask the guy, would you please take these away so I could see?
Yeah.
But he admitted that there was nothing that would convince him
Yeah.
that the immune system could have evolved. I mean, that's how, at least he was honest about it, but that goes to show you.
Well, he's honest about it, but what he was actually claiming was even more fundamental. He was claiming that nobody had done any work on the evolution of the immune system.
Oh, yeah, that's true.
That was the real problem that he had, that he claimed nobody had done any work on it, and yet he ended up unable to see over a pile of research papers on the very subject that he said nobody had done any work on. And
then at the end, and then at the end of it said that wouldn't convince him. Nothing would convince him. And you're just like, well, why are you testifying if you'd rather believe in your own little fantasy?
Yeah, and the other thing about Behe was he did exactly the same thing with his book, The Edge of Evolution, in which he formulated the argument about HIV not having evolved any new proteins. And yet it has. It was a viral protein that has evolved, that people were actually studying. And Behe hadn't read any of the literature. So he was claiming that something didn't exist when there were research groups all over the place actually studying it because it did. And it was a grad student that wrote to him and put him right. It was a grad student called Abby Smith who was actually working on the viral protein. It put him right on it. Here is a new you say there are no new proteins. Here is a new protein. And
Wait,
that
was it one of his grad students?
No.
Okay.
But that's the thing that bothered me, because he'd already been caught out not having done his homework about the research done on the evolution of the immune system. And here he was being caught out again on not having done his research on HIV. And he was making a claim about HIV that wasn't in fact correct. And so to make that same mistake twice, and Edge of Evolution came out in 2007, so that's only 2 years after the Dover trial. And that was a public humiliation for him, that immune system business. You would think he would have remembered the lesson and done his homework.
I believe there's a beneficial mutation found somewhere in Africa that produces a resistance towards like the HIV infection.
There is.
I mean, yes. I just forgot the exact term for it. But you know, see, the gripe I have with this whole creationist evolution thing is like it's sort of like with, you know, the Bill Nye Ken Ham debate, in which, you know, they said they have the same evidence, they just look at it differently, you know, producing like a set of presuppositions. But it's not that. It's not like when biologists actually look at the biosphere and try to understand it, that they presuppose that that since evolution is true, that means there is no God or anything like that. It's the fact that life dies, organisms that are unsuited for their environment won't be able to pass down genes, and those who do will reproduce with variation, and this variation accumulates. I mean, that's the demonstrable thing that we're actually seeing in the natural world, and could actually be demonstrated not just in the natural world, but also under laboratory conditions. I mean, we've seen this with E. coli bacterium, we did it with laboratory mice, with fruit flies, and various other model organisms. I mean, if they want to say that this is the case, and that there was a literal global flood, and that organisms are really designed by a creator, they must bring in direct empirical evidence, and they have to be willing to change their minds in light of new empirical data. And that's the whole thing behind how the scientific method works.
By the way, I've forgotten George's second question. I'm so sorry, George. This is what happens when scientists start talking. The second question was, if we ever want to establish permanent residence on Mars, do you think it will require us to permanently change the human genome for the colonists in order for them to adapt to the harsh circumstances there? So basically creating a new human species, perhaps. I'm really sorry, George. I'm so sorry about that. So who would like to tackle Mars?
Maybe is the best answer I could give. I think if we were able to develop technology to do that, and I think we probably will in the next century, that would probably help. But I wouldn't go as far as to say it would be necessary. And of course, depending on what kind of habitats that we build there, what kind of terraforming that we might do, that could change things.
And also, we tend to adapt.
Yeah.
You talk about we adapt the environment to ourselves, but also we're able to actually build ourselves containment facilities where we could have our own little mini Earth in a dome.
Right, and let's not forget there are a number of moons around gas giants that we could likely inhabit, given the future and advances in technology. I think it'd be more a chance of us changing the planet to suit ourselves than changing ourselves to suit the planet. But who knows, given 2,000, 100,000 years, who knows?
Yeah, I mean, that's what we're doing on Earth. We change the environment to suit ourselves. I mean, I live in Scotland. It's cold and wet. We have houses. We have wellies. We have raincoats. We have very thick clothes for the winter. You know, if we didn't have that, then basically Scotland certainly wouldn't be inhabited at all in the winter. Because without the clothes and the shelter, etc., you know, so we're able to actually take measures to protect ourselves from those environmental changes that would affect other animals.
Now, it is true, though, interesting, that Caucasians, especially from the northern climes, tend to be a lot more furry.
Furry?
Furry.
Yeah, my husband's furry.
Yeah, and you know, but that could be an adaptation. But then if you look at the other peoples, such as the Inuit in Alaska, they are not furry, but they wear a lot of clothes. So it's not a necessary change for humans to live there, because the Inuit are fine with not being furry, and a lot of northern peoples are furry, and that just happened to be an advantage, perhaps, and they stayed furry. But it's not a necessity.
I mean, the other thing is the Nepalese, who are able to exist at lower oxygen concentrations, as in higher altitude. So, I mean, you may start, I think maybe naturally, you might see some changes occur to humans if they were living on Mars. I mean, I have no idea what the gravity is on Mars. I'm assuming it's going to be much less than the gravity on Earth, given that it's a smaller planet. So, I mean, you might get some changes, but to actually genetically engineer humans, I don't know.
And part of the question is, would we know enough to do the right thing?
Yeah.
Change one thing that you think, oh, well, this particular thing here will make it easier for people to live in a low gravity, but that could have an effect elsewhere.
Exactly.
And that's where the real problem is, I think.
Yeah, I think that's why we would end up changing the environment to us rather than us to the environment. I mean, and the problem is that when we make changes to the environment, it takes much longer well, obviously, to see the long-term effects and if it's detrimental or not. But I think in the short term, I don't think we would be able to even try it to change humans. As you said, there's too many ifs and buts about it. Genetic engineering it's a dicey subject. I mean, we struggle just in cloning gene fragments into a bacterium.
You know, I think longer term, though, that I could definitely see that happening with, especially if we get to interstellar exploration, colonizing other planets. I could easily see us hacking our genome to make us more adaptable more quickly.
I think we need a lot more knowledge than we've got, though.
Yeah, I have very high hopes for it, but we've got a ways to go.
Yeah, honestly, what we need to establish first is that I mean, there is some lines of evidence that suggest that, you know, there could be other life on other planets, but I think the main thing we have to do first is to understand you know, what that was, what traits did it have to maintain itself, what possibly got rid of it. But before we start talking about, like, you know, moving to other planets and then altering our you know, the genetic traits that we have, we need to figure out that first. We need to take a gradual, step-by-step type of approach to this.
Yeah, I just remembered something from a book by Anne McCaffrey, who I love. She wrote a book called Dinosaur Planet. Most of her books, of course, were you know, about her and dragons and stuff like that. But on this planet, they had some low-gravity people who were raised in low gravity. And I don't remember if they genetically adapted them or not, but one of the things they did was they gave them an increased muscle mass so that they would be able to deal with low gravity. Or no, they were high gravity people. Sorry, wrong way around. They gave them an increased muscle mass so they could deal with high gravity. And the reason I just thought about that is because there is a mutation in humans and in other animals that causes a doubling of muscle mass. Some of you may have heard about that little boy who's like 4 or 5, and he's like really buff and muscled. And there's a mutation. It's also in whippets, and they're huge. They just have this huge muscle mass. So, you know, it could just be that we discover that certain mutations that are already there might be advantageous, and we might select for those.
It got weirdly silent all of a sudden.
Yeah, Fiona's went to the bathroom.
Oh, I just wasn't sure if I wasn't sure if you heard what I said.
That's fine.
So those are drifting out. Yeah. Anyway, you guys heard about Ray Comfort calling Stephen Hawking an idiot? Not an idiot, a fool.
Well, yeah. Look who's doing it. Look who's doing it. You know.
Look who's talking, Banana Man.
Incredibly deceptive. He's shown to be deceptive. A number of people have approached him, and he goes, well, and he'll say, and even King Croc that's happened with, he'll say things like, well, you know, I'm just a simple guy. I don't know much about science. And then later,
shut up.
Yeah, and exactly. But then later he'll do one of his stupid little movies, which are 30 minutes long, so I don't consider them movies, where he talks as if he knows a lot about science. So you're either one thing or another, Ray. I mean, we know you're a deceptive liar. He's already been caught changing the questions that he asks people. How many people have seen this? I don't know.
Mm-hmm.
But he asked some people who were, I think atheists. He asked some people a particular question, and he interviewed them, right? And they gave their answers. But then when he made his little movie, he recorded different questions.
Actually, he kind of shot himself in the foot, like with his second discussion with Matt Dillahunty, because I love bringing this up because when he commented after, you know, the making of his evolution versus God thing, he said, oh yeah, those scientists, they gave me evidence of speciation and adaptation, some stuff we all believe in, but not one bit of evidence for Darwinian evolution. It's like, dude, that is the evidence for evolution.
Yeah.
I mean, like he accepts it. He accepts evolution like on accident, and he doesn't even know the exact terms to use or for his little script. I mean, it's ridiculous. It just demonstrates his own ignorance.
Yeah, and then he continues to promote creationism, and then he continues to make these lying movies, because it was that movie, that Evolution versus God, that he did this bait and switch with the voice. He asked in the recorded version, the version he put out to everybody, questions he asked were completely different. So it made the people who answered the question seem very immoral. And it was something about if you were given the choice to kill someone for money or whatever, and in the voiceover he made it sound like, well, if you were given the choice to kill someone for money. In the other case, it was like, well, if you had to kill someone, but I forget the exact original question he asked, but they were going to die anyway, or something else was going to happen. So yeah, but you cannot believe anything he puts in any of his videos. It's that simple.
Yeah, that was a Potholer 54 video, right?
I think so, yeah. And some of you may have seen a bunch of us watched his Evolution versus God, and then we did a hangout afterwards where we discussed what was on it, and it's hysterical. Paul Hartley and myself and a bunch of others, and you can't miss it because the first thing we do is we're laughing so hard we can hardly talk.
Wasn't that one of the Friday fails?
No, it wasn't a Friday fail.
Oh, it was some of the same people. It was just some of the same people.
Yeah, it was the same group. Yeah, the same group of people. But yeah, we watched it online, and then we just could not. Poor Paul.
I saw that. I saw part of that hangout. It was pretty funny.
Wasn't
the laughter.
Wasn't that a part of the old Line Go show?
No.
No. Not at all. No, nothing to do with that. No.
Okay.
I'm pretty sure it was on my channel. I forget.
Yeah, it was on your channel.
It was on my channel. Yeah, and it was so funny. We're just dying laughing. And Paul kept saying, and they got some guy's dad! You know, that older guy. That's some guy's dad they dragged in. It was hysterical. And we kept pointing out the most accurate thing about the entire movie was the tape that said caution in the background.
Tommy's made a comment.
Oh,
boy.
More than please, let's just forget about him.
No, it's
That's
an interesting question. I mean, I've typed.
Let's see what the old tinfoil says.
But what is saying that it's not simply that genes and genomes change over time, but rather that purely naturalistic mechanism is responsible for the said adaptive change. If evolution simply required that we believe that genes change over time, everybody would be blah blah. Right? Okay. Now, the comment I've put is the purely naturalistic mechanism is that dead animals don't breed. That's it in a nutshell. Dead animals don't pass on their genes after they're dead. And so for that reason, if you have a mutation which is detrimental, you are not as successful in breeding as those without the mutation. So you leave less offspring. And so the effect is that your mutation would then be diluted out of the population simply because you're producing less offspring than the wild type. And the same thing is going to happen for a mutation that gave you a benefit. You will leave more offspring than the wild type, and so your numbers within your percentage within the population would increase because you leave more. That's it. It's the one thing that you just have to remember for evolution is dead animals don't breed. It's not difficult to understand. As I think it was Richard Raspberry said, this isn't rocket surgery.
That's awesome. That is really awesome.
Gold right there. That's gold.
I wanted a video where he said that.
I can't remember.
But
it's probably a year ago.
If circumstances change, then what could have been detrimental traits could become advantageous. And you've often mentioned rats who are resistant to orphan.
Yes. Because it's change within the environment can alter the selection pressure. And that's what has to be remembered. Now, it's not a case of the environment is consciously saying, okay, I'm going to change myself so that I can get rid of this bunch. It's not like that. It's not like that at all. But a lot of people seem to think that there needs to be some consciousness making this decision. That natural selection has to have some sort of consciousness. It doesn't. It's just what works will stick around, and what doesn't work won't. And as I said, dead animals don't breed. I mean, no, I haven't tried breeding dead animals. I mean, it's not something that I've spent a lot of time trying to do, on the basis that all of my life experience has told me that dead animals don't breed. But if Tommy would like to go out and falsify that statement, then Tommy, you be my guest.
David, are you okay? Are you okay, Dave? What, are you laughing at what Fiona's saying or something else?
Yeah, I'm laughing at what Fiona's saying. I'm laughing at the idea of Tommy going out and trying to get 2 dead animals to breed. It's in my mind. No, stop falling down. You've got to stand up for him. No, you stop falling down.
That's funny.
And the problem is, how dead? I mean, is it one of those things that, well, you know, it's dead but intact, or are we going to be shoveling up roads?
Mostly dead.
Hey guys, you want to hear something funny about Tommy Hall?
Oh dear.
I remember getting into like a comment, a kind of a comment war with him, where we were talking about how like medicine is like conspiracy theory and all this stuff, and I brought up like the diseases that have been recently alleviated through vaccines, right? Smallpox, rinderpest, and recently polio in India. And he actually brought up the guy who actually cured smallpox with the smallpox vaccine. So he acknowledges that vaccines work, but he refuses to accept that medicine is actually important or worth anything. And specifically with vaccines, because the theory of evolution is how we developed those things, because we use them to kill things that evolved, like viruses, bacteria, etc., things like that. But apparently it just doesn't fit his like his worldview, so he rejects it, ironically.
Hey Tommy, I damn near died from measles. People need to vaccinate their kids. As far as I'm concerned, after what I went through, if you don't vaccinate your kids, that's child abuse. And if you want, I'll go into a really excruciating detail of what I went through.
Mm-hmm.
I was 4 years old. What started when I was 4 years old. And I'm hard of hearing to this day because of that. So, yeah, you know, my mom was afraid to let me go outside when I was a baby because polio is everywhere. You know, anyone wants to talk about how vaccines are dangerous or whatever, you just talk to me. As far as I'm concerned, it's child abuse if you don't vaccinate your kid. I've seen too much. People forget. People have such short memories. I grew up in a time where a lot of kids got polio, and a lot of kids died or were seriously injured from things like measles and the mumps. And a lot of guys, fellas, became infertile because one of the side effects of mumps, especially in you get it when you're a teenager, is you become sterile. So, you know, this is so absurd and so terrifying to me that people cannot accept that vaccination is a good thing. And let me just say this, if you do not vaccinate your kids, you need to tell everyone you come in contact with that you do not vaccinate your kids, because you are a danger to society, because you're a danger to older folks like me who have a reduced immune system. You're a danger to babies who cannot yet have the shots. And people have been sued for not telling others that they did not vaccinate their kids, and then someone got sick and died because they caught something from your unvaccinated kids. Now, to my knowledge, no one has actually won a lawsuit. However, I am aware that a number of people have been completely impoverished, losing their house and everything, by having to defend such a lawsuit. So if you don't care about the population at large, you might want to protect yourself and your finances by making sure you know that everyone you come in contact with to everyone you come in contact with, you do not vaccinate your kids. You're a danger to society. Very harsh words, but they're true.
Yeah, there are those in society who cannot be vaccinated because they have a defective immune system, and their only protection is herd immunity. And by not vaccinating your children, you then increase the risk to those who are unable to be vaccinated. You've also got the elderly. I mean, their immune systems are compromised. And so even having been vaccinated or having had the disease previously, they can still end up becoming infected. And that's something that isn't taken into account. And I think that if you want your child to be unvaccinated, and yet your child will be benefiting from the herd immunity of everybody else getting their child vaccinated, you want everybody else to take the risk for you. And I would say, in that case, I could make a case for not allowing you to benefit from the herd immunity. In that if you are not prepared to take the same risk as everybody else within the population, then you can go and live in an unvaccinated community. And again, that sounds harsh because it's the children that are going to be affected. But the problem is that those children within the community who cannot be vaccinated, brand new babies can't be vaccinated. Their immune system doesn't really mature until 6 to 9 months. And so there are many vaccines they can't be given until they're older. So all those new babies are all at risk if the herd immunity drops below a certain level. And so by choosing to not have children vaccinated, you put all of those young babies at risk. You put other children's people at a higher risk than the risk you're willing to put your children at. Because the vaccine risk is very, very small. But the risk of the disease is higher. Sorry, this is one of my pet rants.
It's one of mine too because of what I've been through, and because it's so stupid, and because it does endanger people who are. There are a lot of people with compromised immune systems for a lot of different reasons, including the elderly and the very young. And I wish that the schools would crack down on this more and stop allowing people to, if you wanna, okay, as far as I'm concerned. Here in the United States, that people are, you have a right to a public education. And that includes children with disabilities, which is a good thing. So as far as I'm concerned, if you're like, say, LA County or a large enough county, perhaps you should have an unvaccinated elementary school and then make sure all the other kids in the elementary school are vaccinated. Because this is just too scary. And one of these days, mark my words, as my grandmother would have said, mark my words, somebody is going to be sued for involuntary manslaughter, because their baby, their beloved little baby that they waited for and adored and cuddled and hugged, and that little baby is going to die because some complete idiot out there didn't vaccinate their kids and passed on measles or something like that to that little baby. And when that happens, someday, it's already happening, by the way, it is. One of these days, somebody is going to be arrested for involuntary manslaughter for that. And they may not be convicted the first time around, but I guarantee you, once that floodgate is open, it'll continue to be open. And not only that, for those of you who care about your schools, your politics, and your money in your communities, one of these days, schools are going to be sued for the same thing. Because if you've got your child and you send them to school and they get measles, and if they go through anything like I did, people are going to sue the school for allowing their herd immunity to go so low. This is already being talked about here in California. There is a map of schools in the LA district it's really terrifying how low the herd immunity is. And people are talking about this and saying we've got to change this. So yeah, if you don't care, I mean, this really makes me angry because this is just simply a human rights issue, a basic, you care about other people and other people's children issue. If you want to homeschool your unvaccinated kids, okay, that's your business. But again, if they go to the park or anything else, make sure people know they're not vaccinated. But things are going to change because it's starting to get really serious. There wasn't a big fuss made before, but when you look at the percentage of the decline in herd immunity in some of these major schools, people are getting upset. And there's going to be lawsuits. If you don't care about other people's children, care about your own finances, and the fact you may end up in jail.
Yeah, but also you've got to bear in mind that if you have an unvaccinated child and then you go on to have another child, that second child, when they're very, very young, is at a much higher risk because they are going to be in the same house as an unvaccinated, susceptible child. And if that unvaccinated, susceptible child, they're more likely to bring it home. And so they're actually going to be putting subsequent babies at risk. Because those babies can't fight the diseases. I mean, some of the effects on newborns of basic childhood diseases, as we call them, they're lethal. They're absolutely lethal on new babies because they don't have that immune system to actually protect them. And this has actually brought me onto a subject that might be interesting to cover. Ebola.
Oh yeah, that is an interesting subject.
It is. And I was looking this evening at the news coming out of Texas that one of the healthcare workers has now tested positive. The person who cared for, was it Daniel, who died?
Yes.
Yeah. And we've also got a healthcare worker in Spain who treated 2 missionaries. And she's come down with the disease. And for the Spanish case, it seems that the nurse managed to touch her own face with a gloved hand. Yeah.
Hello, everybody.
And that's
prudent.
And that's worrying, because if you are nursing someone with a Cat4 pathogen, you should be able to do that. And in the Texas one, they're saying that the person was wearing, the full gear. So we're assuming proper hazmat suit, full thing, face sealed in the law. And I don't think, do any of the hospitals actually have the facilities, Category 4 facilities, whereby you have an isolated air supply?
Right. Well, and one of the there's 2 things in Texas. One is that they're now saying that the worker did not follow protocol. I'm not sure what they mean by that, or if they're just saying that to try to cover. But one of the arguments at that hospital in Texas is people were saying, you need to move that patient to the hospital that has the appropriate care facility. And the doctors at the hospital are saying, oh, no, we can handle it here.
Mm-hmm.
So a lot of crap's going to come out of that.
Yeah, I mean, I'm just having a look.
Yeah, I don't see any questions.
I'm just having a look at any Texas updates. I mean,
yeah, check on that.
They're confirmed. The Texas worker is confirmed.
Well, there's also a number of concerns about the way that the authorities in Texas handled the case in the first place.
Yes.
A whole bunch of stuff that went wrong there. Now, it
oh,
doesn't
yes.
necessarily mean they were at fault. Let me be clear, because if somebody comes into the hospital with flu symptoms, the first thing you don't say is Ebola. However, you need to question somebody like, and where have you been lately, sir?
Well, that's the worst thing. He told them where he'd been.
Yeah.
And he still sent them home.
Yeah, I know.
Yeah, but as soon as I heard this afternoon that the Texas healthcare worker had been confirmed as a positive, me and my husband looked at each other. Now, he's never worked in medical microbiology. But I just said to him, and what's the most hazardous part of dealing with this? And he said, when you're removing the protective gear. Because it's the most hazardous part of it all. Putting on your brand new clean gear, that's great. Going in and nursing the patient in your gear, that's great. But when it comes to taking it off, you are going to end up in the same room as all your protective gear, but you're not going to be in the protective gear now. And the only way to be sure is to have an exit from where the patient is, where you basically stand and get fumigated.
Yeah.
And then you remove the protective gear. In other words, you've got to get rid of what may be on the outside of the protective clothing before you take it off.
And maybe that's what they meant by not, and maybe that's what they meant by not following protocol. And I don't know who said that. I forget who said that, because it may have been the hospital. It may have been the Center for Disease Control.
The Centre for Disease Control have said that if a healthcare worker has caught it, then they can't have followed protocol. And because if you just go into that room and strip off contaminated clothing, then you're going to have problems. You're making some terrible noises, Becky.
Oh, sorry about that. I was moving some stuff around. I thought I was muted.
But I'd like to know what containment facilities the Texas hospital has, because I'm actually just going to look up the Cat 4 rules. I've only worked up to Category 3, and that was bad enough. Cat 4 pathogens. Right, oh dear. Let's just have a look. Cat 4 pathogens. Let's see what we need to work with. Right, biosafety level 4. Okay. Here we go. Right, the entrance and exit of a level 4 biolab will contain multiple showers, a vacuum room, an ultraviolet light room, and other safety precautions designed to destroy all traces of the biohazard. Right? And multiple airlocks are employed and are electronically secured to prevent both doors from opening at the same time. All air and water services going to and from the lab will undergo similar decontamination procedures. And I mean, I do know that you should actually have negative pressure, so that if you open a door accidentally, the air will rush in to the containment lab and not come out of it. Can you lot still hear me, or have we got lost?
I'm here.
Oh, you still here? That's okay. I just wondered, because David was just saying he had no audio, so I think he's gone out and he's going to come back in. So that, I mean, I'd like to know what facilities that hospital actually had, not just for the hazardous waste disposal, but actually getting out of the protective gear. That really is the danger point, where the unprotected you can come into contact with the contaminated surfaces of all the protective gear that you've just taken off. So that'd be interesting to know. And I think a lot of people are quite concerned because I think it's going to be spun into, oh, it must be airborne.
Oh my God, they did that with AIDS.
Yeah, because it seems to be that is what they're going to do. But I think the problem is this. The authorities have actually downplayed the risk. It's very hard to get because you need close contact, exchange of bodily fluids. But the problem is that it's actually quite easy to get, because somebody with Ebola is spewing out bodily fluids by the pint. You have to remember that what's going on inside their body, especially in the fulminant cases, is that their organs are turning into mush. So the bloody diarrhea that they've got and the bloody vomit that they've got, it's not just blood, it's their innards are liquefying. And it's all got a high viral load. So you've got somebody who's really, really ill, with blood pouring out of their eyes, their nose, their mouth, and every other orifice that they've got. It's a lot of liquid. So it's very easy to get bodily fluids onto your protective gear. And that's, I think that's the thing that I think hasn't been taken on board. I'm not trying to say that it's completely contagious and it's airborne and all the rest of it. It's not. But I think by downplaying the risk, you can make it much, much worse as well. I think they have to have screening at airports now. They've got no option. If you look at the graphs of the cases recently, the last I looked, there was a beautiful exponential explosion, and then it looked as if it had gone straight, actually it's a straight line, but the next figures could take it, actually keep the exponential bit going. It's got all the, it's got the classic, the graph is the classic shape of an epidemic. And the reason that this outbreak's done it is because this strain of Ebola isn't as nasty as some of the previous strains. And so people are wandering about in the infective stage because they don't feel as ill at the beginning of the infective stage as they did with other strains. With other strains, the high temperature hit and they were prostrate. They were ill. They were going nowhere. And you were talking about mortality rates of 90% and above. With this strain, the first symptoms aren't so sudden and severe, and so they're wandering around for a bit longer, shedding the virus. And this is why this one's taken off. They're looking at a mortality rate of maybe 50% or below.
And that's scary.
Mm-hmm. So it means that people will be walking about, and you know yourself, you've gone to work when you've got a slight fever. I mean, we've all done it. A slight fever, and so you can go to your work. And then you begin to feel an awful lot worse, and so you go home. And this is what's happening with this strain of the virus. And that's why it's spreading so much.
I was just commenting to me about something.
Oh boy.
But this is the pattern that we see with a lot of epidemics. When syphilis was first introduced into Europe.
You're very quiet.
Oh, okay, hang on a minute. Let me fix this. Okay, can you hear me now? Okay. A lot of people know that Europeans brought a lot of diseases to the Americas, but some people don't know that the revenge was syphilis. Syphilis came from the New World to the Old World when it was first introduced into Europe. It was horrific.
Mm-hmm.
People had blisters all over their body, and the death was like nearly 100%.
Yeah.
Sorry,
you talking about syphilis?
Yeah.
Yeah, you were dead within 10 days.
Yeah.
That's why smallpox is called smallpox, because syphilis was the great pox.
Yes.
Yeah.
But we adapted, it evolved. That's what happens with epidemics.
Mm-hmm.
You know, nobody thinks of syphilis as being an instant killer anymore.
Mm-hmm. And I think it's possible that could happen with Ebola. But the difficulty is this, that the previous outbreaks have all been stopped. And so when the next one pops up, it's coming from the source again. So any evolving that it had done is out the window, you know, as it went through humans. So you go back to source. And so you would end up going back to the very virulent strain. For some reason, I mean, I think the fruit bats carry a number of strains, and it just so happens that this one that's got out this time isn't as virulent. But it's very much up in the air because we're still in the very early stages of this. Yeah, it's actually saying that they've only tested positive at the hospital. They are waiting for CDC to confirm it. Somebody posted that in the comment section. So I think that it'll be quite interesting to know about that one. But somebody else has pointed out in the comments, if a vaccine is developed for Ebola, will the anti-vaxxers take it?
Yeah, probably not.
If they don't, then they could deal with the consequences. I mean, they're the ones stupid enough to deny modern medicine.
Yeah. But that is an interesting question, isn't it?
Mm-hmm.
And the other thing is, given that obviously you're not going to be able to vaccinate the elderly and the very young and those children who have a compromised immune system, whether it's genetic or whether it's because of leukemia or they're undergoing chemotherapy or whatever, given the risk to them, would the unvaccinated be allowed to remain within the society, given the lethality of this virus? Or would we just quarantine a lot of them?
That's a really good question, and I think it may change our attitudes towards some of this anti-vax crap.
Yeah, because you look at how many people could be put at risk by anti-vaxxers. And look at the demographic of those who would be getting put at risk. The really young babies, the very old, and the sick. And given that we want to knock this on the head, we've got to stop it. then anybody who doesn't get vaccinated isn't taking part in attempting to stop the disease. They could allow it to keep going, keep rumbling on. So,
and I'd like to point out that we already have a history of dealing with things like this.
Sorry, say that again?
Oh, I was going to say we have a history of dealing with things like this, and we already have laws in place that could adapt. When tuberculosis was running rampant, people were arrested and taken to tuberculosis sanitariums, whether they wanted to go or not, because they were considered a danger to society.
Yep. And look at Typhoid Mary.
Yeah, I was just about to mention Typhoid Mary, same thing. But we can do that, and we've done that with some people who are out there passing on AIDS, or HIV, really, you know.
Yeah.
Who have not bothered to, they've been arrested for that and quarantined. So we already have laws in place that can allow us to quarantine people who are a medical danger to society.
In fact, New Jersey's just used those laws. Did you hear about this?
No!
Oh, it's brilliant. Do you remember the NBC cameraman? I think he came down with Ebola. He was flown to the States for treatment. Right.
Yes.
Right. Him. He was hired by the crew, the NBC reporting team. And the day after they hired him, he came down with symptoms. Now, the entire NBC team, they're back in the States, and they were asked to go into voluntary quarantine, and they agreed. And then one of them decided to breach the quarantine. So they've now had mandatory quarantine imposed on them. So one of the team chose to actually break the quarantine rules. And I was furious when I heard that one.
Oh, yeah.
Because they've obviously been in reasonably close contact with the guy who, within 24 hours of being hired, had symptoms. And you know that you're infectious when you have symptoms. And they broke the quarantine. David's asked in the side chat, if the virus is so weak, how is it spreading so quickly and with such deadliness? The reason it's spreading so quickly is because of the way it kills people. They end up spewing out pints and pints of liquid with a high virus load. And so it's very easy to get some of that liquid on you if you're nursing someone. And as I say, that liquid has got a very high viral load. So all you need to do is transfer a little bit of that to a mucous membrane. So the Spanish nurse who apparently touched her face with a gloved hand could have transferred virus to the skin on her face. And then all she needs to do is rub her eye or rub her mouth later on in the day. And that's it. And the reason it's so deadly is just because of the action of the virus and what it does. And each cell that it infects and uses as its slave to make more copies of itself, it kills. And one cell can make thousands of copies of the virus. And then those 1,000 copies will go out from that one cell, killing it, and infect 1,000 cells. And then from that you'll have 1,000,000. And then 1,000,000,000. And so basically, with all the cells dying in the liver, in the kidneys, in the spleen, you name it, the GI tract, the organs liquefy into soup because the cells are all dying. And that's where these large volumes of virus-laden liquid are coming from, and that's why it's being passed on. Just the sheer volume. I mean, you know yourself when you've got a sick kid, you know, it's thrown up and you've got to hold the bowl for it. More often than not, you get it on you. Sorry, wrong end of the cigarette in my mouth.
Oh, that's not good. You're right.
Good job it wasn't lit. I did that the other day.
Okay, that's good. That's good.
I did. I was looking at, and I was actually looking at the lit end, and then I put it in my mouth. Do you remember that hangout where I had a lit cigarette and I did that and I burnt the end of my nose and squealed? Yes. And somebody said, "What happened there?" And I said, "I've just burnt my nose with my cigarette." They said, "How did you do that?" I said, "I did that and I burnt it again."
Oh, Fiona. Oh, no.
I know.
That's interesting.
Yeah, you think you'd learn from, I mean, to demonstrate how I did it and to do it, I mean, just no. Just gonna do that. Just gonna know. I mean, it was
So is the
absolutely
virus
ridiculous.
contagious before you start showing symptoms?
They say it isn't. Oh, sorry. They're saying that you're not contagious until you start to show symptoms. First symptom being an increase in your temperature. The problem with that is, in those that have caught it, like the Spanish nurse and the Texas nurse, they've noticed an increase in their temperature and they've presented. But we don't know how long their temperature's been going up for.
Well, how do you know the difference between those symptoms and regular flu symptoms? Because you would think you'd have the regular flu. So you're contagious.
You won't know right away. You won't know.
So you're contagious.
Yeah.
And you don't know that you have this Ebola. You think you got regular flu and you're spreading it around.
Yeah. And I mean, those healthcare workers, if their temperature was up at 37 and a tiny little bit, they could have been infectious, but they didn't even notice that their temperature was slightly up. So there's always going to be that window. I mean, I'm actually quite good at telling when my son was running a temperature, just by putting my hand on his forehead, and I could tell his temperature was up. And when I was checking,
is this why you're concerned about people getting vaccinated if they ever come out with a vaccine? Is because of during the time period where they don't think that they have it, but they do?
No, that's not what I'm concerned about with the vaccine. The problem is this: if there are a bunch of people who are anti-vaxxers, okay, and they're going to refuse the vaccine, okay, the whole point in vaccinating everybody is to stop them getting the disease, okay? But it's also to stop the outbreak in its tracks, because the more people that are vaccinated, then the more chance of the virus coming into contact with somebody who is going to be immune to it and can fight it off, so the virus just can't get a toehold. If people refuse the vaccine, that leaves a susceptible population that the virus can multiply in. And within our population, we have groups that cannot be vaccinated for health reasons or for age reasons. For example, newborn babies. They can't be given a vaccine. Their immune system isn't mature enough for them to mount an immune response. And this is why we don't vaccinate brand new babies against measles and mumps and etc. They get their vaccinations later because they don't have the immune system for the vaccine to actually poke into life.
Okay, now what about all this talk about the chemicals and things that are in the vaccine that are supposed to be preservatives that end up causing harm, like side effects and stuff like
No. For a start, I think it was thimerosal everybody was moaning about because there was a tiny bit of mercury in it. The amount of mercury was minuscule. It's no longer in vaccines. And on top of that, this whole anti-vax business goes back to Andrew Wakefield and the MMR vaccine. Now, Andrew Wakefield went public with his claims about the MMR vaccine in the January. And he was advocating that instead of using that triple vaccine, that they should use a single measles vaccine. That was in the January. What he didn't disclose was that 6 months prior to that, in the June of the year before, he had filed a patent for a single measles vaccine.
Okay, do you recall back in the President Ford administration back in the 70s where they tried to vaccinate people for a certain kind of flu that was going around, and it ended up causing people to have permanent damage, and I think it killed a couple people.
The thing is this, though, what you have to remember is that with any medication at all, there is a risk. But the risk from the medication is less than the risk from the disease. And the current hysteria over vaccines all comes down to Andrew Wakefield and the MMR vaccine. That's what's spurring on the anti-vaccine movement at the moment.
Well, I never heard of this Andrew Wheatfield, I think is what you said. I heard some stuff from like conspiracy gurus like Alex Jones and people like Glenn Beck.
No. Well, I mean, Andrew Wakefield has actually been struck off the medical register in the UK because of what he did. I'll give you a brief rundown. His study linking the MMR vaccine to autism, okay? He had 12 children in the study. 12, okay? One of them had never been given it, the MMR in the first place, at all, hadn't been given any vaccine. And another child in the study had been given the single measles vaccine. So straight off, there's 2 of the 12 aren't actually eligible for the study. Now, all these children have been self-referred by their parents that they had autism and some sort of bowel symptoms. And what Andrew Wakefield did was, he looked at these children and he asked himself the question, how many of these children had been given the MMR vaccine? And the answer was a very high percentage of them. So he concluded that the vaccine caused their autism and bowel symptoms. But he'd have been just as well asking.
I thought you were born with autism.
Yep, but no, it seems to turn about 2 years old. But he would have been as well asking the question, how many of these children drank milk as babies and then made the link? Correlation does not equal causation. The fact that they all drank milk cannot be said to have caused their autism. The fact that the majority of them have been given the MMR vaccine doesn't mean that that caused their autism. And the worst of it is this. He took those children into an operating theatre under general anaesthetic without fully informing the parents of what he was doing. They thought he was treating this bowel condition. He wasn't. He was wanting biopsies for his study. He put these children under general anaesthetic and he took tissue biopsies from their colons. One of the children almost died because he perforated their colon. There was no treatment involved. He was not treating these children. He never informed their parents of that. It was not informed consent. This is why he's been struck off. On top of that, They then said that they had used a PCR to detect the measles virus in the samples. I've actually looked at the results of their real-time PCR reactions. Every single one of them is on the baseline. They are not positives. Anybody with any experience in real-time PCR would have looked at those graphs and said, that's a negative. Andrew Wakefield, there's a threshold. Once the line on the graph goes above a certain threshold, you call it positive. And the machine itself, based on your controls, sets the threshold. And what he did was he manually moved the threshold way down after the machine had given its threshold, so that these wee wiggly lines that were almost horizontal would just creep above that threshold. In other words, he pockled his data. He committed out and out fraud because he wanted to make money from his single vaccine that he already had a patent for before he even did the study. And the money that funded his study was provided by a law firm who were acting on behalf of parents who were claiming the MMR had caused the autism in their children. So basically, he was paid the money to find the evidence that they didn't have at that point. And because of what that man did, this is why we've got all these vaccine scares.
I think you should go to jail if this is actually what happened. I think you should go to jail for it.
In fact, you can go and have a look for it on YouTube. Look for a guy called Concordance. He has got a video out which shows the actual real-time PCR data that Andrew Wakefield got. And you can see for yourself what a positive should look like, what a negative should look like, and what Andrew Wakefield's data looked like. And judge for yourself. And you will see that they were negative. And that is to actually manually drop the threshold. He dropped the threshold down into the level of background noise.
Okay, what nationality is this man?
British.
He's
But
British.
he now lives in Texas.
Well, I don't know if the British government has anything like the FDA, like we do here. Food and Drug Administration.
No, he's been, this has been, and the worst of it is, America's all up in arms with MMR, right? We dealt with this in the 90s. That's when Andrew Wakefield first published. I think it was 97. And we dealt with this. And he was completely debunked. And he's gone to
So
America.
why isn't he in jail?
Because, to be honest, he should be, if you ask me.
Yeah, it's
He
difficult
should be.
to find a crime to actually charge him under. That's the problem. Like, it's someone's indirect actions. Like, yeah, what he did was bad, but you can't directly, even if he was responsible, even though so many anti-vaxxers cite him, you can't throw someone in jail for that.
Yeah, that's the problem.
Okay, well, we have laws about people who won't allow people to get medicine come to religious beliefs. Didn't this man sort of cause the same kind of situation?
Yeah,
Well, it's not this. It's
yes and no, I would say.
complicated.
It is.
If he's making people believe that vaccines are bad, which I kind of believed for a very long time, then they're not. Then they could get sick, and they could be harmed or even die.
Yeah.
And it's his fault. And it's his fault.
Yeah, exactly.
Just like it's a parent's fault who don't let their kid go to a doctor because they think they can pray the child to get better.
But I mean, and this is the thing. What he did is so bad, And it was all for money. And the other thing he had done was that he was developing a kit. And this kit would be available for parents to test their children for this autistic bowel syndrome that actually doesn't seem to exist. And he worked out that in the first year alone, he could make $41 million from selling this kit. The paperwork's all there. In fact, now I'm trying to think what channel it's on. It might be on Cliffjumper's channel. There was a journalist by the name of Brian Deere who blew this whole thing wide open. And in fact, at the moment, Andrew Wakefield is suing him in the States. So Andrew Wakefield, a British guy, is suing a British journalist for an article in a British newspaper. Even although Andrew Wakefield's been struck off. And even although his case against journalists in the UK was thrown out by the UK courts, he's now going to sue in the US. But for something that
I
was
don't
done
understand
in Britain.
that.
Neither do
I
I,
don't understand that.
it'll be thrown out because it's for something that was done by a British citizen on British soil. Now, on Cliffjumper's channel, I think it is, Cliffjumper and I interviewed Brian Deere. I say we interviewed him. Basically, he was brilliant. We didn't have to say very much because he just told his story. So this is straight from the horse's mouth, the journalist that blew the gaff on him. And it's the details that have come out from that, you know, what he talked about in that, are absolutely mind-boggling. And yet, because the US tends to look in the way and not out the way, the US didn't know that we were going through all this. Okay? And they're not aware of just how destroyed his reputation is because of what he did. So he's now over in the States and he's stirring up all this anti-MMR hysteria.
I don't get it at all.
And the US is still unaware that Britain went through this in the 90s.
I don't think it should even matter if the U.S. is unaware because it's not our business. It happened in Britain.
No, but the problem is it's now affecting you in 2014.
Right.
His research was discredited completely in the UK in the late 90s and the beginning of the 21st century. Discredited.
So the guy who made this lie is suing.
But
can I, please, can I?
Yeah.
I just looked it up. His lawsuit was thrown out.
It
turns out, okay, first of all, it was thrown out. He was able to file because of something called the Texas long arm statute.
Right.
In most states, he would not have been able to file. The lawsuit was thrown out by a judge, and in September of this year, last month, her decision to throw it out has been affirmed by higher courts.
Yes. There you have it.
He's gone.
Yeah, and that's the point. Because, I mean, I'm reasonably up on this. And yet I didn't actually know that a judgment had been handed down. And what we have here is the UK debunked him, completely and utterly debunked him. And now he's doing it to the States, and children are at risk in the States. And that's why what happened in Britain is important to the people in the States. Because what the States are now doing is reinventing the wheel.
Yeah. Oh, and by the way, let me add that Wakefield was ordered by the courts to pay all court costs for everyone.
Good, because if that hadn't happened, I was going to be on a campaign to raise money for Brian Deere's court costs.
Yeah, no, Brian Deere's court costs are covered. Andrew Wakefield has to pay his own court costs and Brian Deere's court costs and anybody involved. So, yeah, there you go. What an
Right.
idiot! I mean, why bother to sue? Your reputation's already destroyed. I mean, I don't understand why he would think he had a chance there to do anything. Even with that
I'm looking it up. Right, where am I? You got a link here?
Oh, actually,
got it?
Wikipedia on Andrew Wakefield has it.
Right, okay, excellent. It's been
And
updated.
it's at the bottom. I already closed it, I'm afraid.
That's
But
okay.
it's
There's an article
if you go
in the Statesman.
Yeah. Okay.
And there's also a New York Times article, I think. Let's have a look. Yeah, he was stripped of his British medical license in 2010. And now he cannot sue in Texas. He was trying to sue an editor and a reporter for defamation. And the article that he was saying defamed him was raising substantial questions about the accuracy of Wakefield's 1998 study that indicated a possible link between autism and vaccines.
A study that was pulled by the journal that originally published it.
Yeah, well, it's been thrown out because
Yeah.
the publications concerning Wakefield's conduct and activities that occurred in England and Texas is never mentioned in any of the articles. So Texas courts lack jurisdiction over the defendants, which is what I just said. Woohoo, I'm glad I was right. And the other thing was that because of the case in the UK, Brian Deere got access to medical records of the children, with certain information redacted, of course. And they were actually sitting in the solicitors reading this and discovering that things that had actually been marked down in the records as negative had been changed to positive. And Wakefield, I can't even remember how he did it, but he basically got the court something weird, and it meant that suddenly, wallop, Brian Deere could no longer see the medical records of the children. But and that would mean he wouldn't be able to defend himself. But what they managed to see in those records was damning to Wakefield. But as I say, the US are now going through everything we went through. Yes, okay, he didn't get struck off until 2010, but that's still over 4.5 years ago. But his study, I mean, the study came out in the Lancet, and I read it online when it came out, and straight away, I mean, within about 10 minutes of finding the article online, within about 10 minutes, I had found holes I could drive a bus through.
So why is he doing all this?
Money.
I mean, if the cat's out of the bag, I mean, it's pointless.
I have no idea why he's keeping going on this. I mean, the journal that published it was the Lancet. The article's been completely retracted. 10 of his co-authors have disavowed the findings. They didn't know that he was messing with the results.
He'd be smarter to take whatever money he has and run.
He doesn't have any left, I don't think. He's been found guilty.
No, I've never really believed that about people who have tons of money. I think they stash some of it somewhere.
He doesn't have tons of money because he never got away with it.
We said he made $14 million one time.
No. What I said was that in his patent application for this kit that he was going to be selling, he estimated that in the first year that it went on sale, it would get 41 million. The point is that he never manufactured the kit, I don't think, because his entire study was debunked.
So what money are you talking about him getting then, if he's trying to do it
And
for
that was,
money?
he was trying to do it for money and he failed.
But you just said he probably didn't now? Or if he
No.
did, it's all gone?
No, he didn't get any from it. He failed.
He's talking about damages, legal rewards. He tried to do that, and it didn't work.
And he's still trying, in other words.
Well, he's pretty much exhausted his options.
Yes.
He tried using a Texas law called the long arm law.
Uh-huh.
And basically it allows you, for instance, okay, he was denied because none of the articles mentioned Texas in any way. Now, if the article had involved Texas, even though it was printed in the UK by a UK publisher, written by a UK guy and all that stuff, according to the Texas long arm law, he could have sued in Texas. But because the article didn't mention Texas at all, didn't have anything to do with Texas, the law does not apply under those circumstances.
Mm-hmm. Exactly.
So it was a stupid thing for him to do in the first place. And you really have to wonder. I mean, if I were him, I'd be living quietly or go into some sort of other pseudo-medical crap that I could make money on, and rather than stir this up again because you're
Like that
locked.
Kevin dude that sells books on home remedies.
Yeah, or something like that. I mean, because he's...
I forget his name. I bought one of his
Yeah.
books.
Yeah.
And found
But-
out
but
later
he's-
that he actually did time.
Yeah, but see, that's the thing. If Wakefield wanted to make money over pseudo-medicine or pseudo-science, then he should just drop the whole vaccine thing because he's been burned so badly there. You have to wonder why some people do the things they do. Maybe it was a last-ditch attempt to repair his, I can't think of the word. Repair his honor. That's the wrong word. But
Maybe he's
his
desperate to be
credibility.
right. Maybe he's so desperate to be right. Maybe he
Well,
actually
maybe-
believes it.
It is possible he has actually convinced himself he is right. That has happened in the past. But in this case, I'm pretty sure he's lost his, that Texas statute, I'm pretty sure was his last attempt at reclaiming any sort of name for himself.
Yeah, it sounds like he just drove himself insane.
I could have. Can I go back a minute to what you mentioned about the flu in 1970s?
Oh yeah, when President President Ford.
Ford, yeah.
Yeah, he made a law. I was only like 12 years old or so when that happened, but he made a law because there was like some flu epidemic, and
Okay, because I could.
side effects caused people to die and
Yeah,
get hurt
okay.
or something.
I remember that well. It was in 1976 and I was 26. So I remember it well. What happened is it was called the swine flu and it was very scary. Now the reason it was very scary is because even though it only affected a few people at the time, they were prepared for a giant outbreak because apparently at the time they did some research on it and it was related, the type of flu was related to the type of flu that caused the Great Pandemic in the early 1900s, the one that swept across the world and killed a whole lot of people. Okay, and people were terrified of the swine flu. What happened was it was an overreaction, and they developed the swine flu vaccine and they gave it to everybody. Which I didn't take it. I've read the research of that. Now this doesn't seem to be, that concerning. So people all over the country had the swine flu vaccine. And as it turned out, pretty well, it's about, the claims are it's about 500 people had a reaction to it. It's, can you ever answer how to pronounce it? Fiona might know. It's a Guillain-Barré syndrome or something like that. It's a neurological disorder. And it's reputed that up to 500 people, the number is questionable, caught this syndrome because of a reaction to the vaccine. And that perhaps some died from it, maybe 25. And yes, that's very scary. However, when you look at the number of people who were vaccinated versus the number of people who, because it was a massive vaccination, versus the number of people who came down with this syndrome, it's still very small. However, what really upset people was the flu didn't do much damage. The vaccine ended up doing more damage than the flu did. Now, I'm sure some people could argue that, well, yeah, that's because we got the vaccine out there and we stopped the flu dead in its tracks. So that's why more people weren't hurt. I could also argue that it was 1976 and flu vaccines weren't as good then as they are now. And our understanding of the flu, which constantly changes and can be very scary, is what it is now. But I remember the swine flu scare. It was very frightening. But as it turned out, most of the people who had the disease were only around the area of Fort Dix, I think. But again, you could argue that the reason that the swine flu did not cause much damage, did not hurt many people, is because of the vaccinations. The fact that people came up with this neurological disorder, again, was really unfortunate and had to do with a reaction. Did apparently have to do with a reaction to the drug. I'm not sure what studies have been done on this. I'm really not. But again, was a small percentage compared to how many people had the vaccination. I mean, I think the president got vaccinated publicly to show people not to be scared. So, but yeah, so when you see things like that, first of all, in my opinion, at the time, it was an overreaction by the public, the press, the politicians, and even maybe the CDC, terrified of this potentially deadly flu, because people were harkening back to the whatever the hell it was when we had the Great Flu Pandemic. But it also could be that we just simply stopped the flu dead in its track by massive vaccination. I don't know which side of it is true. The problem is that when you have certain people, I've seen this before, some of these conspiracy sites, they don't look at the whole picture. They just look at, oh my God, all these people were injured by the vaccine and some died. Even if it's true that 25 people died because of the vaccine, again, if you look at that percentage that died because of the vaccine versus how many were vaccinated, and then consider how many people potentially could have died from the flu, as sad as it was for those 25 people and their families, that's the better option.
Yeah, I was listening to a lot of conspiracy stuff over the last 6 or 7 years. I stopped paying attention to it about a year and a half ago when I started to realize just how insane most of it was. So that's where I heard about this autism and the vaccines and all the diseases and stuff. And
it is entirely possible that the swine flu vaccine was a giant screw-up. But it was done for the best of reasons. And I don't know that it's a giant screw-up. I have not bothered to investigate it personally to see what studies have been done on it. But just from what I do know about the flu and flu epidemics, perhaps we just stopped it dead in its tracks. Don't know.
now, isn't it possible that side effects could be caused by the chemicals and things they put in it as a preservative so that they can preserve vaccines?
I don't know. That's an interesting question. I know that really isn't so. That kept being brought up with the autism, thing and the vaccines, and that simply isn't true with autism.
See, I'm not that knowledgeable on autism.
Yeah.
I assumed that you were born with it.
Yeah, well, you are. I mean, that's a good question.
Yes, no.
There's a lot of evidence right now that shows that autism may be an epigenetic disorder. So I don't know a lot about that. I've read something about that. I don't know. I think they're still investigating it. The problem is it tends to show up about the symptoms start at about the time that children get vaccinated. But correlation does not mean causation. And it's possible, you were born with it, but there are a number of disorders that do not manifest themselves immediately. It takes years, not just autism. There are other things that take years. Look at muscular dystrophy, the various kinds of it. You have a little child running around just fine, and then by the time they're 10, they may be in a wheelchair. You don't automatically, and that's as far as I know, at least in Duchenne's, it's a genetic disorder. So just because you don't see it when they're little kids doesn't mean that they don't have it. They do have it. Or, you know, and there are other diseases like that. Huntington's chorea, which is what Woody Guthrie had. And they actually learned a lot about that, sort of unfortunately, because there's some town in South America, I don't remember where exactly, where it is just endemic in the population. Everybody is interrelated, and a certain percentage of everybody has this disorder. Because of that, they were able to do genetic studies on Huntington's chorea and see what its inheritability was and things like that. And they now have a test for it. So people who comes from families with Huntington's chorea can get a test to see if they have the gene for it. But yeah, again, that's something that doesn't even show until you're an adult. So, but it's a genetic disorder. So I can't tell you, I really don't know where autism comes from. It's one of the things they're looking at now is that autism is not a disease, but rather a spectrum.
So are you saying that you could be normal and then, like, say when you're 15, you could be autistic?
No, it shows up earlier. But you could be normal and there are other diseases that can show up when you're 15. But autism shows up when you're very young.
I always figured that.
Yeah.
It's about 18 months to 2 years.
But again, as I said, it's like muscular dystrophy, or at least some of them, like Duchenne's muscular dystrophy. I don't remember when that appears, but you have a perfectly normal kid running around for years, and then all of a sudden they start getting weaker.
Speaking of autism in kids, I don't mean to derail the conversation or change subject, but I just want to know, does anyone ever know if Eve ever got her car for her son?
I don't know. No, I don't know.
Because I haven't heard anything.
Yeah.
Yeah, I think she did, but I can't speak to that for certain because I don't interact with Eve.
Yeah.
I think she got her money goal, but I have no idea if she actually got her car or not.
Well, I know she raised the money, but
Yeah.
I was real anxious to see what kind of car she got.
Well, I don't know.
Just a side note.
Yeah, that's true.
Is this Eve?
Yeah, Eve.
Eve real?
Yeah, she managed to get. It's like a sort of SUV type thing. It's got, I think it's 7 seats in it because remember she got 3 kids to haul around.
Yeah.
And their friends. Yeah, she managed to get something.
Good.
She had trouble with the battery recently, but she got that fixed. I'm really pleased she's got that because she needs it. She really does need it.
Yeah, because
Right,
try to do public transportation with a child with autism has got to be incredibly difficult.
Yeah, I think in her video, she mentioned that one of the main issues she has is the constant cleaning up after the child.
Oh, it's not just constant cleaning up. I mean, I think there are all sorts of issues that she needs to deal with, and one of the things is that the poor wee soul freaks out on public transport.
Yeah.
And because the child isn't quite looking at things the way everyone else does, he's more susceptible to a predator.
Mhm.
Yeah, that too.
Yeah. Right. Let me see. We've actually got questions. I hadn't even noticed it. It was 38 minutes ago.
Oh no.
Let's see. Of course, there's quite a few. Oh, good grief. Oh gosh, yeah. What do you think about stopping flights until Ebola's under control? Ooh, that's a difficult one. Yes, if you want to stop it in its tracks, but I don't think it'll work. Too many people will complain about it.
Well, it would bring commerce to a halt.
To a complete standstill. Also,
You can't do that.
Yeah, and also you're going to have the problems of trying to get aid out to the places that need it. I mean, nobody's going to volunteer to go out and help if they can't get back into the country.
Right. And
So, I mean,
you have sort of, I was going to say, you have sort of an advantage in the area of the world that it's occurring in. Because if this was occurring in Germany or France or the UK or even here in the United States, that would be chaotic and would bring all traffic to a halt. It would. But there aren't that many flights in and out of that area of Africa, so it's easier to quarantine those particular flights or to quarantine people from those particular areas.
Uh-huh.
That's what they need to look at. They need to look at all forms of transportation, not just flights, all forms of transportation out of that area and control that.
And so, because the further it spreads locally, then the more chance there is of it getting out. Obviously, they need to keep it confined to these really small areas if they can. But I think was it Liberia has declared defeat, and what they're now doing, they're handing out gloves and painkillers to families so that the families can nurse the victims in the home, because they only had 304 isolation beds. And they've got no option now but to not take in any more patients. They're going to have to be nursed at home. And I mean, to be honest, they're saying that all the people can do is put on the gloves and push a packet of Tylenol towards the patient. But who's going to do that with a family member who's really sick?
You're not, especially with your child.
Exactly. And so I think you're going to have to say the infection rate in those circumstances is just going to rocket.
In that case, the only thing they can do is try their hardest to deal with the dead bodies.
Yeah.
I'm thinking of the Black Death.
Yeah.
Back then.
And another question was, are there any prominent anti-vaxxer in the YouTube atheist theist hangout community? And would we hold a hangout to address and refute their arguments? Yeah, that might be a good one. I know Tommy's an anti-vaxxer, I believe. I'm sure there are others. George, this is a poor guy, I keep missing his questions. Do you think Saudi Arabia allowing people from Nigeria to go on the Mecca pilgrimage this year? Because Ebola is a lower risk than other African countries, is going to spread Ebola.
I think that's something that needs to be considered, and I hope the people at Mecca and the people who are letting people into the airports of Saudi Arabia. Remember, Saudi Arabia is a wealthy country, so I think they should be able to handle this situation. That's a very good question, though, and I hope they're on it, because that could be very scary. If you've seen those masses of people at Mecca, oh my goodness.
Well, the reports coming out today are saying that Nigeria has succeeded in containing it.
Well, they didn't have a lot of cases in Nigeria. It was mostly Liberia and the Ivory Coast.
Yeah, apparently it is now officially Ebola-free, according to the Nigerian health minister. What is that racket? Is somebody pounding on a keyboard?
Nope.
Might have been me.
Just mute when you're not talking.
Who has got something playing in the background?
Well, everybody's pretty much muted now, so
you still hearing it?
Yeah, it's a Sears advert. Could whoever is listening a Sears advert, please mute your microphone. Okay. That's Becky.
What? Can't be me. There's nothing on here.
Becky, it's you.
No, it can't be because there's nothing on.
I hear something too, and it's certainly not coming from me.
No, it's coming from Becky because the camera's activating on her.
Oh, really? I wonder what it is.
It's something about Ebola in Nigeria.
But I have nothing on.
Hold on, I'm going to mute you, right?
No, she muted it. It's definitely her.
Right, so it's...
Nope, it's coming from you. It's coming from you because I can hear it.
Me? I've got nothing open. I've got absolutely nothing open.
Okay, that was weird.
It's gone. What was that?
Hey.
That was very odd, wasn't it?
Anyway.
But yeah, so apparently Nigeria is Ebola free. I'd like to know how long it's been free for. Let me see. Yeah, they only had one case, did they not? A guy who flew in from Liberia. Yeah, it was the Liberian finance minister, I believe. Is that right? He was part of the government anyway, and he boarded a flight with a temperature when he shouldn't have. And he flew to Nigeria, and Nigeria quarantined everybody he come in contact with. Am I right in thinking that? Would somebody like to speak, or have I frozen?
Oh, you're not frozen.
That's okay then.
Okay, no, I did put a link up above to the CDC, and I thought Nigeria had 2 cases. I can go back and find it. Let me see. Whoops.
Yeah, I've only found one.
But yeah, Nigeria had only just a couple of cases at most, and they were caused by people, travelers.
Yeah, yeah. So that's it. No, it was Nigeria had a single case, according to CDC.
Oh, well, that's good. Yeah.
Yeah, it was a single case, and it was
a
government official from Liberia who boarded a flight with a temperature contrary to all the rules of his own government.
Right.
So that's not good.
Yeah. We may have 3 here in the United States.
Oh boy.
There's somebody I don't know. There's somebody being treated in Nebraska, and I don't know if they flew in with it. I mean, I don't know if there's someone who was taken there. We have the case in Texas, and we may have a case in Massachusetts. May have. I'm not sure yet.
I was still waiting for confirmation of that one.
Yeah.
Right, I'm just checking out to see if there's anything new. Yeah. Dallas. What? Hold on. Let me see. I'm just reading this. There's a new report that's come out. I'm still waiting for oh yeah, they've got confirmation from CDC on the Texas healthcare worker this afternoon.
Okay.
So it's been confirmed. So now they're saying that other hospital staff could have been exposed because they don't know what's going wrong in this.
Well, either it's
the lady's been identified, which is a shame.
Yeah, it's possible that even
Yeah.
if they were wearing the suit, they weren't wearing it properly. And as you said, taking it off is the scary part.
Yeah, that is the scariest part. So they're now going to have to look at this of what happened after that man was admitted to hospital. Apparently the guy who died in Texas had very high levels of the virus. This person is showing much lower levels, but then again, you would show lower levels at the start of it. So, this is, but apparently, I mean, this lady had extensive contact on multiple occasions with with Duncan, who died. Yeah, the Spanish case, the nurse has said that she may actually have made a mistake when taking off her protective suit. That's really sad. It's just the fact that you know, it's known that that's the danger point. And to think that it fell down at that stage, it's really sad. Anyway, guys, I'm going to take this off here because I'm tired. I want to say thanks to everybody for coming along. It's been a really good discussion. Thoroughly enjoyed it. I'm just going to check, make sure there isn't a question lurking in the background I've missed. Where are we? Oh, somebody's asking about Ebola being a biological weapon developed by the US. Have you ever dealt with this kind of conspiracy nutters? Yeah. And the best argument against that is, what use is a biological weapon if it's going to affect you and your troops and your people just as much as it affects everybody else? And I think that's why I would say that I don't think this is a biological weapon, this latest outbreak. If it had suddenly broken out in Alaska, then yeah. But it didn't.
If it's going to be a biological weapon, it's more likely to be the Russians or some shit, isn't it? I mean, respect to the area and so on.
Yeah.
That's what I don't get about any of those kind of suggestions.
Yeah, and also, as I said, there's no point in using a weapon that's going to kill your own people as well.
Exactly.
It's such an indiscriminate weapon. And also, you can't control it. Once it's out, you can't control it. Because of international travel, there is no way that you would be able to contain it. Because every single person has the potential to be a virus factory. As soon as you release it, it's out with your control.
You do realise this is leading into the realms of Illuminati.
Yes,
Bring
exactly.
the population down to 5 million kind of shit and so on.
Oh.
You just encourage those bastards.
Yeah, that was that question. Somebody underneath the live stream on YouTube, somebody has put a link to Concordance's video about Wakefield's fraudulent research. They've put the link. The video is called Wakefield's Smoking Gun. So if anybody wants to have a look at that, it's a really, really good video.
By Concordance, right?
Yeah, by Concordance.
Oh, I love that channel. He is so real.
Well, you'll find it in the comments underneath the live stream of this hangout. And if you go and watch that, and you'll see the PCR results, and it's stunning. You know, there's no question about it. It was deliberate fraud. End of. I think that's.
I've already seen the video, but yeah.
I think we've done all the questions. I can't see any more. I mean, I'll check back through this later on, and if there's any that I've missed. But I don't think I have. But I'm going to take it off here now anyway. So thank you everybody for coming along. It's been a really good discussion. I thoroughly enjoyed it. And I'd like to thank everybody that was in earlier who's had to depart for all the information and for giving their time and their effort to at least trying to answer some science questions that people have. And it might be worthwhile doing a hangout like this again, possibly in a couple of weeks' time. That'll give people lots of time to think up science questions. Things like, how does protein synthesis work? Things like that. So anyway, thank you very much, everybody, and I hope anybody who watches this has actually enjoyed it. Ta-ta!